Hello and welcome to another one of my Emacs videos. In this video, I'm going to show you a package I'm calling consult-omni for doing omni-search similar to macOS Spotlight or Alfred, but from within Emacs. This is a follow-up to what I've shown before in this channel with Consult Web, but with a lot of new functionalities and features. Now, we have a lot to unpack in today's video, so I'm going to try to break the video into smaller sections. So if you're not interested in certain parts, you can fast forward and just watch the parts that you're mostly interested in. With that said, let me just pull up my screen and jump right into it. All right, I have my screen up here, and in this first part of the video, I'm going to show you how I use Consult Omni without getting into the details, just to do a comparison with other omni-search tools like macOS Spotlight or Alfred. So let me first pull macOS Spotlight and do a search for a term like Emacs. So when I do that, I get some suggestions up here for completion, and then down here I have results from apps. It does give me suggestions for maybe doing a web search by jumping to Firefox, and then looks at applications and files on the desktop like this emacs.pdf file, websites, and etc. I can of course also do here some other interesting searches. Maybe if I want to do some quick calculation, I can say 2 plus 3 and I get results directly from the built-in calculator for Mac. Maybe you can even do, let's see, sine of 30, and you get results for that, and that's, I guess, radians. So let's see, sine of 30 degrees is 0.5. You can also probably do some unit conversions. Let's try that. 10 degrees of Fahrenheit equals to minus 12C, and 50 degrees of Fahrenheit equals 10 degrees of C, or maybe even, let's say, 20 USDs. You can see you get conversion to other currencies from Yahoo Finance. So you can see that there is a bunch of interesting sources here that you can get results from by just running the search in macOS Spotlight. Now, if you're not on a macOS system, you can also use other tools for omnisearch like Alfred, which I also have it available here just to do some comparison. So here I pull Alfred and I say Emacs, so I can see results from apps. If I want to get suggestion for search, I can do search Emacs, and now it suggests maybe searching it on Google. Let's see if I say 2 plus 3, I get results from calculator. Or if I want to limit things to calculator, I can also say equals 2 plus 3. And then let's see, sine of 30. Yeah, I can get results from the calculator as well. Let's see, can we get conversion? That did not work, and this does not seem to work. But there are extensions and workflows and plugins for Alfred that allows you to do a lot more than what is available on macOS Spotlight. You just have to install those, and for using those features, you probably also have to pay for a license for Alfred before we can use that. Personally, I don't use neither macOS Spotlight or Alfred anymore because I prefer using Consult Omni and Emacs. So now let me pull that up, which I've bound to command space, and show you how that works. All right, so here is my Consult Omni search tool with so that opens an Emacs frame, and I'm down here, my cursor is down here in the mini buffer, and I can start typing. And I start getting results right away. You can see I'm getting results from node files that I have on this machine. I am getting results from apps. I have GPTel, which is an AI chatbot. So if I get a preview of that, I see results from, in this case, from Grok. I'm getting results from GitHub repos, for example. So if I get a preview of that, I can also see the README right here in Emacs in an org buffer. Then I get direct results from Wikipedia. So if I do here, you can see opening this page on Wikipedia within Emacs with XWidget WebKit, for example. And then I have results from Brave and Google search. In this case, I have also results from my email with using mu4e. So maybe if I get a preview of that, I can see that email right here. And then we also have some results from NVIDIA's, which is doing a YouTube search. So for example, let's see, maybe if I open this one, and maybe I pause that video, I can also see that YouTube video here. I believe I also have results from my Alfred feeds. So here, for example, is a video from the System Crafters channel that is in my Alfred feed. Now, I can also do here what we did before by doing something like this, and I get results from the calculator. Let's see if I can get sine of 30. All right. So that works. We can also do conversion, but I'm going to come back to that a little bit later when we talk about the calculator and all sorts of different things that we can use the built-in calculator here. I can also then search for consult, and we can see the results again from different sources. So we have this dynamic completion here, and right away we get results from any of these sources. And the sources and pretty much everything here is customizable. And in the following parts of the this video, I'm gonna show you some of these customization and some of the features that are built in consult-omni. All right, now let me cancel that. The next thing that I'm going to show you here is another utility that I also use consult-omni for, and that's as an app launcher. Since we already have some app searching in consult-omni, we can also integrate that with our desktop and use it as an app launcher. For example, here I have made some custom gestures to pull the app launcher that looks like this. This is again another Emacs frame with just a mini buffer. So here I can start typing Firefox and it narrows down. And if I enter, it opens Firefox for me. All right, let me minimize that. And here I do it again, Visual Studio Code, and it opens Visual Studio Code for me. Let me close that. So you can see that with the same package, not only I get the omni-search tool, I also have an app launcher. It can also be some other things depending on how you make scripts and integrate that with your desktop using Emacs and consult-omni. So with that said, now let's go back and take a deeper look at all the features and new functionalities that are introduced in consult-omni. All right, now that I showed the basic demo, let's go a little bit in more details and see all the bells and whistles that comes with consult-omni and how you can customize things and what are the sources and the commands, etc. So let me pull up Emacs here, and I can open my show notes, and let me increase the size here so you can see. So before we start looking into the details and doing some examples and codes, let me just say that if you want to try the package, you can open the GitHub repo for consult-omni, which I can just pull up right now. And there is the README is quite detailed, has all sorts of examples for how to set things up and what are the different sources, and some examples and screenshots for how to use the package. So for just installing the package and testing it out, you can just refer to the README for now. It does not contain all the details that I'm going to show you in this video. That would take a little bit more time to document all the details for each source, and especially for some of the new sources. but for just installing and using the package, the README should be sufficient for now. You can also look at Consult Web and my previous video on this same channel. So let me go back here, and I'm going to post these show notes on YouTube under this video, so you can download it and you can refer to it later. So I have a link to my previous video on Consult Web right here, which you can also watch. It compares Consult Web with some other packages for doing web search in Emacs, and also gives you some examples for everyday workflows. I think if you watch those and give the packages a try, then it might be more interesting to you. The rest of this video might be more interesting to you, and it would be easier for you to understand and follow along with me. All right, that said, the next, and as you can see, I have a bunch of topics to cover, so let's just jump right to it. The next part that I'm going to talk about is a little bit understanding the design and some slight differences between Consult Web and Consult Omni. Okay, so let me open this tree here, understanding the design. And the first part here would be talking about dynamic versus static commands. So on this setup, I have both Consult Web and Consult Omni, and right now I'm going to open Consult Web Wikipedia. As you can see here, we had two interactive commands with Consult Web called Consult Web Wikipedia and Consult Web Dynamic Wikipedia. The difference is, and I will show you in a little bit with Consult Omni examples as well, that with the one that has dynamic in its name does dynamic completion versus the other one that does not really do dynamic completion as you're searching. We have changed that in Consult Omni a little bit just to keep things a little bit more intuitive and more consistent. So in this case, now we have Consult Omni Wikipedia and Consult Omni Wikipedia static. So we switched the names. Now the one that says Consult Omni Wikipedia without any suffix is dynamic, and if you want the static command, then you will add the static suffix. So let's just start with this static example here. When you run a static command, it first asks you for a search term. So let's say Emacs. And then it goes fetch the results from the source, in this case Wikipedia, and shows the results to you. At this point, you cannot change the results or the search query with static commands. You can, of course, still do narrow down, similar to what you would be doing in other mini buffer completion. So here, if I type editor, it narrows down on the candidates, but the total number of candidates and the search term I used, those are fixed with the static commands. If I want to change them, I have to cancel this, go back and run the interactive command again. But with Consult Omni Wikipedia, if I type Emacs, I can get results for Emacs, and then I can go back and change this to something else. So let's say Consult Omni. And now I get some other results. I can also pass variables here. So if I say Emacs with this syntax of dash dash from consult, and I say, I give it a key count. Note that right now I'm getting 5 results. That's the default in the package. But if I say count 10, now I can get more results. And if I change it to 20, I see 20 results. I can also say count 2 and page 2, and now I only see 2 results, but this is page 2, meaning that it's from number 3 to 4 in the total number of results that I'm getting from Wikipedia. So this is a lot more versatile. You can, by changing what you type in the mini buffer prompt, you can adjust the results you are getting, and this is the main, since this is more powerful and the main intended use for this package, we changed the naming so that that when you run consult omni Wikipedia, you get by default the dynamic completion. And if you want the static version, and there are some use cases maybe static is preferred, which I will show later, in those cases you have to call the static version. All right, so that's the first thing to understand about dynamic versus static command. Next, we're going to talk about async versus sync. So with console web, what we used to do, and let me fix this typo right here, depending, we used to go over each source, especially with multi-source searches. We used to go over every source, collect results from that source, and then concatenate all the results together before showing it to the user. So that means that if you had like 5 sources and you were collecting 100 of hits from each, you had to wait for all 500 results to be collected before you could see the result. But with consult-omni, we completely changed the backend design of how we collect the results, and we are running it in parallel with async processes. So we run processes in parallel to collect results from each source, like Wikipedia and Google and Bing. And as the results arrive, we show them directly to the user without waiting on other sources and other results. So let me try to show that in an example. So here I am going to run Consult Web Scholar using the old process where we were collecting all the results in a synchronous process, and I'm searching for quantum sensors with a count of 200. So this Scholar command will look on PubMed and Scopus for like academic literature, and I'm asking to search for quantum sensors and get 200 from each source. And because I'm asking for 200, it's probably going to take a while before all the results arrive. So when I run this, you will see that it will take some time for Consult Web to collect all the results before you can see the results. And that kind of makes it feel a little bit slow, especially if you want to get a lot of results from a source. Now note that in this case, we only got 226 because the Scopus limits the number of results that you can get per page. So it only returns 25. And if you want more, you have to change the paging of your request that you send to the Scopus server. But PubMed does return 200. So in this case, we get 200 from PubMed, 25 from Scopus, and 1 from Jupyter. Now I'm going to do that exact same search, but this time with Consult Omni, which uses the new async process and shows the results as they arrive. So when I do this, you can see that I see the GPTL result, then a Scopus, and then PubMed. So that kind of happened quickly. So let me increase this to maybe 600 or 500. And I'm going to run this again. And you can see that the GPTL results is already here. Scopus is coming next. And we wait, and now the PubMed results arrive. Let me cancel and run that again, because I want to show you that while we are waiting for other results, we can interact with these results already. Look at the previews from GPTL, for example. So now this is much faster, much easier to interact with, and much more intuitive because you're not waiting for results for all the results to arrive. And that would also mean that now we can also use sources that tend to return a lot more results than just I don't know, something like a Wikipedia search. So let's take a look at one example. For example, here I'm running a grep command on my home directory for Emacs, and because I have a lot of Emacs related files on my in my home directory, I'm going to get a lot of results, maybe tens of thousands of results. But as you will see, as the results are arriving, I can still interact with what is already here and even look at preview or open them. I'm going to cancel this because once it hits 30,000, 40,000 results, it may slow down a little bit, which is partially because of the way we are doing things. If you use, for example, Consult Grep, you may not have that problem. But in a Consult Omni context, you probably don't ever need to look at 40,000 results. You probably want to limit the number of things you're looking at. This is just to show you how Consult Omni is is faster and better than consult web by using async process, because now we can also have other sources that return many more results. Now, one drawback of this is that because we don't have all the results up front, we cannot order them nicely and consistently to show. So for example, if I run that same query again, this time in a multi-source search with also GPTel, Wikipedia, and Brave, you can see that, okay, the grep results are coming in and I have GPTel, Brave, and Wikipedia, but the order, and let me cancel this now, but the order is not the same order as the sources that we defined. And the results, and the reason is because we are showing the results as they arrive, and the timing of when each results arrive is not always consistent. It depends on how the server behaves on that day and time that you're running the search, and etc. This is something that we can probably fix in the future, but for now, the order of the sources is not necessarily defined by what you define here in this command. So here, for example, I run the same command and I have a different order for sources, but when I run it, you will see that the order of results did not really change. But no worries, you can always use vertical cycling to jump between different sources and different groups, so you don't have to depend on the order of the sources. Now, I can also show you another example of this just to see this timing of arrival. So here I'm going to search for Emacs. Let me decrease this to 2 for or 3 for now, see how that works. So in this first command, I'm running consult-omni multi with the query term Emacs and only getting a count of 3 from each source. And the sources are GitHub, Brave, GPTel, and Wikipedia. So when I run this, you can see the results here. I have GPTel, Brave, Wikipedia, and then GitHub. All right. Now, to show you why we ended up with this specific order, even though the order that we had up here was GitHub, Brave, GPTel, and Wikipedia, why we ended up with this order, let's run that same command again, but this time I'm turning the grouping off by passing this variable gnil. So when I run this, now you can see the candidates as they arrive. So we first get the GPTel results because this is simply making a string. It's not really making a server call at this point until I get a preview. But the Brave source did return one candidate, and then before other Brave candidates get there, we got some results from Wikipedia. Then we got more results from Brave, and then eventually the results from GitHub arrive. And that's because of the performance of the GitHub client command versus calls that we are making with HTTP requests to Brave server versus Wikipedia server. Now, if you keep repeating this same command, sometimes you may get results from Wikipedia before you get this first result from Brave. And in that case, the order of the results you see when the things get grouped will be different. So for this reason, the consistency between the groups when you're grouping the results are not always the same. And the order is not always consistent, but you can always either turn the grouping off if you're not interested in that, or when you have the grouping, you can use vertical cycling, which by default is bound to Shift Tab to jump between sources without worrying about. Here, when I run this again, I can show you. When I run Shift Tab, it just jumps to the next source. So regardless of the order, I can quickly go find the source that I am mostly interested in. All right. So that's async versus sync. And next, we are going to talk about multi-source collections. All right. So multi-source collections. So with consult web, another difference between consult web and consult-omni is that with consult web, I was providing some alternative interactive commands for multi-source searches. I have simplified the design a little bit. So now it's up to the user to define other multi-source searches if they want to. So by default, consult-omni comes with consult-omni multi and consult-omni multi-static. And if you want other multi-source searches similar to the Scholar that we just saw, you need to define that yourself, but it's pretty easy to do that. So for example, if you want to define a consult-omni Scholar interactive command, you can just use what I have here, where I use consult-omni multi, and I just pass a string for the mini buffer prompt, and then a list of sources. And the rest of them and other arguments are passed on to consult omni multi, similar to what you see here. So if I do this here, then look for consult omni's color, and you can see that this prompt that I put up here is shown here. I just, in this case, I put just the graduation hat because it says Scholar search, and it can be anything. It can be any string that you like. It can even be a function that returns a string. And in this case, if I do this same search that we were doing, quantum sensors again, I will get results. And since I'm not changing the counts, I'm getting 5 results from PubMed and 5 from Scopus. Okay, so that's pretty good. Now, depending on your workflow, you may be interested in multi-source searches that use a different set of source for different purposes. For example, you can define a local multi-source search where you're only looking at local files or apps. So in this case, for example, I define one where I'm using like node search, apps, and some grep commands. And then you can also then define a separate one for the web. Maybe you want to have one for Brave and Wikipedia and Google and GitHub and Alfred. And you can see I am changing these prompts depending on each function. So when I do consult omni local, I can see here what is the command, that I am using. So since this says consult omni local, I know that I'm doing only a local search. So if I do Firefox, for example, I should see some results for the app right here. And since I am on macOS, I'm also using mdfind command here. And then for web, consult omni web, I can say, let's search for consult omni, see what we can get. Since I have the GitHub sources right here, you can see I get hits for GitHub repositories, and that the top one is the consult omni repo that I'm talking about right here. And then I have some from GPTel, Brave, etc. So depending on your workflow and what you're interested in, you may want to define different interactive commands with different set of sources, and it's pretty straightforward with this consult omni multi command that you can just pass a string for the prompt and a list of sources, and you will get a new interactive command. One more thing that might be interesting to think of is you can also do some let binding around this consult omni multi, and so for example here I'm changing the consult async split style to comma. So here if I look at consult async split style, you see by default it's Perl, which uses this pound sign to split the mini buffer input to search, what is used for searching and fetching results, and what is used for narrowing down the candidates. But you can change that to comma. Let me open this. You can change that to comma or semicolon to change the behavior. And why is this useful? So here, let me use this consult omni web, and when I run consult omni web, so now you see that this pound sign is not there anymore, which means I can right away use narrowing in this case. So for example, if I say G space Actually, I don't have Google there. So let's say B space, and now you can see that it says Brave. Now I'm only searching Brave. So if I do Emacs, you will see that I'm only getting results from Brave. And if I go back here and say web search in Emacs, I am only getting results from Brave. And then I can use the consult narrow key that I've bound to meta O. And it gives me an option for all of them. And if I do meta O again, I'll go back to using all. So this is useful because now, of course, I can also say H and I get GitHub. I can say W and I say Wikipedia. And if I do backspace here, I go back to all. So this is useful for if you're used to something like what you would be doing in DuckDuckGo and some other search engines when you can quickly pick the search engine you want. You will get the similar behavior here by just changing the consult async split style to comma. Now let me go back here and maybe explain this a little bit more with the Perl style. So now I'm not let binding it anymore. So now you can see that there is this pound sign Perl split style there. And what that means is, so if I search for Emacs, now I can put another pound sign. And what I put here is now going to be used for narrowing from the candidates that I have here. So if I now do resources, you can see that it's now narrowing from the results that we have. So this is why it's useful to have something like this Perl split style. And if you change it to comma, then instead of pound sign, you can use comma to separate search query versus narrow down term. And in fact, if I run this again, now the disadvantage of the Perl is that here I cannot do what I was doing before with B plus. And even if I go before here and do it, it does not really work. But what would work is that if I remove this pound sign, use B space, and then use the pound sign again to do Emacs, and then the second pound sign for narrowing. So this is not as convenient since you have to remove the pound sign and then put it back in. So if you want something similar to some other sources where you can quickly use one key to narrow down the sources, then you may want to do this let binding of the split style to comma, for example, or semicolon. And then you can just right away, when you run the command, you can start use one key to narrow down the results. Now, of course, with this consult-omni multi, and by the way, consult-omni multi, let me actually run something here. If I just say consult-omni multi without any other okay, I made a typo here, consult-omni multi. If I run consult-omni multi, by default, it uses the default definition for the list of sources that consult-omni multi uses. So let me actually look for that consult-omni multi sources. So this is a customizable variable. So by default, I have set it in my setup to include these sources. So when you run consult-omni multi without any input, you get results from those sources. But if you want to change it, then you can quickly run this with giving it an initial, which can be nil, and then a list of sources, and then some more other variables that you can look into in the documentation. What is the use cases for those? In this case, no callback means that the function that you run will not really run the callback on the candidates that you select. It just returns the string of those candidates itself. All right, so you can define maybe one for just doing searches in Emacs for buffers and org agenda, and maybe mu for E. Maybe you want to find define another one that is for Omni. Here I say local. Let's change this to Omni interactive omni-search, where I have both web sources like Brave and Wikipedia, and also local sources like, for example, running repo all. So that and by design, the consult-omni comes with this customizable variable, consult-omni default interactive command, which you can then bind it to any of the interactive command that you defined or the one that comes with consult-omni. This means that once you do this, then you can run consult-omni command, which is just a wrapper that then calls this default interactive command. So you can quickly find your favorite one, or maybe the most commonly used one that you are interested in, a mix of different sources, and then you can always run that. In this case, mine is now bound to consult omni multi. And again, this prompt here can show you which command is being called when you change this default interactive command. All right. So that's all I wanted to say about the design of the package and some of the things that might be useful to know about how to use the interactive commands that comes with Consult Omni. Next, we're going to talk about sources. There are many new sources that we're going to look at, and each of them come with their own bells and whistles that we're going to review. And then we're going to talk about expanding and defining new sources, but I'm going to do that at the end of the video. As you can see down here, I have some headline for extending sources. But for now, in the next part, we're just going to talk about the sources that are coming with Consult Omni by default. So let's talk about sources in Consult Omni. This everything I said so far was maybe some basic understanding of how to use the package, but now I'm gonna dive a little bit deeper with some of the new sources and how to use some of the features with each source, which might be of more interest to advanced and power users. You can see a list of all the sources on the GitHub repo. In the README, I have listed them. I do plan to write down more detailed manuals, maybe on a wiki pages on the GitHub repo for each source. But for now, I think showing them in this video is probably the best way to introduce all these different sources. I'm not going to show all the sources that I showed before with Consult Web, so things like Google and Brave and Wikipedia. They are more or less the same as what we have seen before. There are some new features that I may show here, but I won't talk about those sources. If you are interested, you can go and check the previous video on Consult Web. Things haven't changed by much since then, except some of the things that I already talked about with static versus dynamic command or async collection of results, but the sources themselves are more or less the same. However, we do have a whole bunch of new sources and a whole bunch of new features that we can talk about in this video. First and foremost, let's start with some async commands that come with consult, like consult grep and consult rip grep. So with Consult Omni, I have made it possible by redesigning the collection of candidates that we can also now use async commands, meaning running command line programs from within Emacs to get results and then showing those results in the mini buffer as candidates. So for example, here, let's first run this consult grep, and I would say consult, and it's searching this the folder I'm in and grepping for the term consult and showing all the different results. And as I go over them, you can see a preview of that file right here. So that's how consult grep works. I have made a counterpart of consult grep for consult omni, and the reason is that we need a different counterpart and we can't directly use the consult grep is because with consult omni we want to be able to combine consult grep and put it alongside other sources, as we have already seen in this video. And for that, we had to redesign some of the sources and how the collection works for them. So then I designed a new command called consult-omni grep. And if I run this and I search for the same term, consult, you can see that I'm getting grep results. The candidates look a little bit different because now you also see the file name here, whereas before you had grouping by file. So when I do this here, you can see that it's consult grep by default is grouping the results by the file name and then only showing the kind of position in that file and a summary of the line that this term consult occurs in that file. With consult omni grep, we show the file name back here, and then the rest of it looks similar to consult grep. And the reason is because when we do the multi-source search, we want to be able to separate grep results from results that come from, I don't know, Wikipedia and other sources. So for that reason, we are showing the file name here instead of using it for grouping. Of course, you can change this if you're only running consult omni grep and you want to get something a little bit similar to what you see with consult grep. You can do this where you do the consult search term and then you pass a variable for grouping to :g, or you can do -- group, and then you say file means group. That did not work. Maybe this would work. Yes, so you can say :group file. And then it starts grouping by the file. You still see the file name without the directory back here. But by grouping with the file, you would get something similar to what you would get from consult grep. But in multi-source searches, now we have the option of grouping all the grep results together under the group grep. All right. Now, of course, with consult, you can get consult grep, or if you have rip grep available, you can also use consult rip grep or consult git grep. I have added one more for consult omni, and that uses a rip grep all. So let me actually first do a search for rip grep all and show you this package. Maybe this one. Yes, ripgrep also. This is a version of ripgrep that is fast, similar to ripgrep, but can also search in PDFs, ebooks, Office documents like Word and PowerPoint, zip folders, and etc. So this is really useful, especially in case of consult omni purposes, because now we can also do a search inside files like PDF files, for example, right? So let me minimize this and go back here. So I have made some files on this folder that I'm in right here, where I have included the term hello world. So when I do consult omni grep all and hello world, now you can see the results here. There are some zipped folders that have files that then include those that term. For example, a demo.txt or demo.org inside this zip folder. And I will also get normal results from, like, for example, this same file that we are looking at, shownotes.org, that contains this term hello world. So let me open this. And of course, because it's a zip file, you don't see, you see something gibberish here. But if here I go and open, this is now a demo.org file inside the zip folder that you can see contains this term hello world and a bunch of other things, maybe the term intelligence. So I can close this, and then I can also open this demo.txt. These are all inside this zipped folder. In fact, let me open this here. If you look at examples folder, you can see that there's this example.zip that has demo.txt and demo.org, etc. That contains those terms. So you can get results from zipped folders, also from PDFs. So let's see here. If I do consult-omni rip grep all with the term consult, I believe we get some, yes, PDF hits. And here, if I use the consult preview, it does open the PDF and jumps to where this word consult is found, and is highlighting it here in the preview for me. And if I enter, I go right there in the PDF, and I can. So this is a very good way of finding contents of even PDF files and Word files, etc. By running a search from consult omni. Okay. Of course, to run rip grep all, you need to have the rip grep all command and package installed on your system, which you can read on GitHub how to do it and how the rip grep all itself works. In terms of performance, it's comparable to rip grep. It's not much slower, so you can perhaps even replace using rip grep with rip grep all. Here is another example that shows that with consult omni, I have also added the option of passing a dir variable to something like rip grep all or grep. So then I am here only searching for, within the folders that I showed earlier that has PDFs for the term quantum sensors, and I'm getting hits for it. And if I go here again, it jumps to that file and highlights the occurrence of quantum sensors for me, and I can see and I can read that part of the PDF that I'm interested in. All right. So that was the first part with grep, rip grep, and similar commands. We also have commands for finding things like find, fd, locate, or if you're on macOS, mdfind. So since here I am on a macOS, I'm going to run consult-omni mdfind and search for the term consult, which finds files in on my desk, on my computer, looks pretty much everywhere and finds all the relevant things that may have consult. This is essentially the backend of macOS Spotlight search. So a lot of the results that you will get from the Spotlight search, you can also recreate it within Emacs by using this MD find. So if I, for example, here, if I open this one, for example, and it's a GIF file, hopefully it's not too big, I can see the file here. All right. And similarly, you can, for example, consult omni locate is useful, especially if you are looking for, let's say, command line programs. Let's say, if I say Emacs client, I can find all the Emacs client.desktop files on my computer, for example. All right. We also have the equivalent of consult man for manual pages with consult omni man. So let me first show you consult man and look for, again, Emacs client. And you can see it found one result for Emacs client. And if I open it, it will open the man pages right here in Emacs. And we're going to do the same thing with consult omni man for Emacs client. And here is the result. And when I enter, I get the man pages for Emacs client. All right. So those are more or less similar to what you would get from consult itself. We just borrowed some of the code from the consult core itself and adopted it for consult omni, so then you can combine these sources with other sources for an omni-search type command. Next, we're going to look at GitHub. For GitHub, I'm using my other package, consult-gh, which let's take a quick look at that. Let's just look at the preview right here. Consult.gh is another one of my packages where it uses the command line GitHub client, the GH command, to search for repositories, for GitHub repositories, or look at issues, etc. We have, of course, if you're just interested in searching for GitHub repositories or interacting with GitHub repositories with the command line client, you can use consult.gh. But in consult-omni, again, we have made some a smaller version of consult.gh for just searching repositories, so that this is now useful for to combine this with other sources in consult-omni. So, and I'm calling this consult-omni GitHub. So if I do consult-omni GitHub and look for consult-omni, I will get results of GitHub repositories that match consult-omni. Or if I do consult-gh, I will probably also get results for, we'll see my consult.gh repository. If we do consult web, we may not see, or yeah, actually we also see consult web from my home packages. Importantly, remember that you can always use embark and embark become. So if you start with a consult omni search for, let's say, GitHub, or in a multi-source search, and then you want to realize that, okay, you're interested in something a little bit more powerful like consult.gh, then I can run embark here and look for embark become, which I think is bound to capital B, yeah. And then I would do meta x consult.gh, and in this case, search repos. And you can see that the same search term that I had before in consult-omni GitHub is now transferred to consult.gh. So now I have all the features of consult.gh. So the same thing applies with other sources like maybe grep and ripgrep sources from consult, where you can start with the consult omni counterpart in a multi-source search, and then if you decide that you want maybe better performance or more features from those original sources in consult, you can always use embark become and go back to consult grep, for example. All right, so that's for GitHub. By the way, part of the nice thing about having all these sources in one package in consult omni is that we can also have some consistency here. For example, when I do the consult omni GitHub search, I can still pass this same variable n10, and that works for consult GitHub as well. And in this case, we are getting only 7, maybe because of how consult.gh is running queries from the server. Sometimes the APIs do not return the numbers that you ask for. Sometimes it's usually, it means when you do n10, it means up to 10. Sometimes it's less than 10, depending on how the API works. Yeah, and the same applies for example, if when I did consult grep, I think we already saw some examples where I can pass a directory to the grep, and that would work for grep and also other similar commands in consult omni. So you have some consistency for searching multiple sources and passing the same arguments to all of them at the same time. Next, let's look at emails. I've added support for mu4e and not much. For mu4e, again, I'm using my other package consult-mu. So if I do consult-mu consult web, I get results from my emails from that have contain consult web. But again, with consult-mu, there are a lot of features and bells and whistles, but we have a smaller version of it within consult-omni called consult-omni mu4e, which when I run, it gets results from my email. Again, in consult-omni, universally, the number of results that you get is 5. Of course, it's customizable and you can change that, but you can also change it on the fly by passing n, for example, n equals 10, and now you get more results. And again, here, because there is some threading in the emails, you may see less than 10 results here, but in fact, it's finding 10 results from mu4e. Okay, and then also we have the same thing for not much. And if I run here consult omni not much with consult web, you can see that again I get results from the emails from not much. So now part of the idea behind consult omni is that instead of running different commands, so there are packages for just running consult not much just to look at emails, or and my own packages of like consult mu to just look at emails, or consult gh just to look at GitHub repositories. Now you have a one-stop shop in consult omni where you can look at GitHub repositories, at emails, at local files, at web search engines, and you can also do it in with multiple sources at the same time in an omni-search approach. So if you start using consult omni, what I have seen in my own workflow is that I rather start with consult omni rather than any of the other sources. And if then I realize that I'm only interested in one specific source, then I can switch either with embark become, or I can cancel and go back and do some run one of those commands. But consult omni is usually a good starting point for me to get this overall overview of all the results from different sources. All right. Next, we're going to talk about searching notes. Now, in the previous video with consult web, I already showed sources for that uses consult, the package consult notes by Colin McLear as the backend, and that still works on consult omni. I just have cleaned up things a little bit. So with consult notes now, if you want to use the consult note backends, you can look for consult omni consult notes, and you can see that we have consult notes denote, consult notes or consult notes commands for org roams like reference roam notes or ZL roam notes, and also the static versions as I mentioned earlier in this video. So if I, let's say, run this consult omni consult notes denote, and let's see if I search for example, I usually don't use the note. I just made some examples for this video. So you can see there's only one hit. This is an example note for consult omni. You get the same functionality that you would get from the package consult notes. In this case, these commands are looking at the title of the note and the file, not necessarily the contents of the file. For looking at the contents in each note, consult notes comes with a, let me see, search. Okay, consult notes search in all notes. So if here I say Emacs, it runs essentially consult grep on all the note files that I have, and groups similar to grep groups them by file name. Now for that functionality, I have defined a new source in consult omni that is under consult omni notes. And the design is pretty simple. You have this customizable variable consult omni notes files that you can set to any directory or list of directories or files. So here I am setting it to org directory, org rom directory, and the node directory. So if I set this, now the command consult-omni nodes is going to search all these directories, every file in those directories, and runs a grep on the contents of those files. In addition, you can also set the backend of this command to grep, rip grep, or rip grep all. So for example, here I am setting it to grep. Let me evaluate that. Consult-omni nodes backend command, I set this to grep, and then I run consult-omni nodes search for Emacs. So this consult-omni node search looks for the contents of each node file, and it's using consult-omni grep. So you see the file name and the content as we saw before with consult-omni grep. Now, if you want, so since we're using grep, let me run this consult omni node search GNU Emacs. So when I run this, you can see I have two hits for two node files that I have. So maybe here I have some notes on running Emacs on macOS or installing Emacs on macOS, and I get results from there with consult omni node search. But then I can change this to RGA. I can change the backend command to RGA, which is the rip grep all command. So if I do this and run the exact same search as before, consult omni node search GNU Emacs, now I'm getting search results from PDFs as well. This is especially useful if you use the node and you have file types that are not just text files in your node directory and you want to search all of them. Then you can use the rip grep all backend and you get results from everything. So here, for example, I have the GNU Emacs manual in one of the folders here. I saved it for demoing this consult omni. And if I enter, again, it opens this PDF and highlights the occurrence of GNU Emacs, and I can read this PDF. All right. So that's pretty powerful for searching nodes, whether you use org or org rom or the nodes or something else for taking notes. This is pretty simple. You just have to set your consult omni nodes files variable, and then you can run consult omni node search, and also the backend, whether you want to use, by default I think it tries to use grep, but you can change it to RGA, for example, and then you can search all sorts of different files to get results. Now right here I'm going to also show you there is a new thing in consult omni, and that is that you can also have new candidates. So for example, let's see, I'm going to run consult omni node search with this term, a novel node. And it doesn't find any results because I don't have the term a novel node in any of my node search that I'm using in this demo. But when I hit enter, you see that it jumps into an org capture buffer. And if I, let's say, okay, this is a personal node, you can see that it puts a novel node right here in the title for my org capture, and it's using my default org capture templates as I would normally be doing with a org capture command. All right, let me cancel this because I don't want to make that node right now. All right. Now, if you want to use some other backend, so maybe you don't want to use org capture, maybe you want to use org rom for creating new nodes, then you can also customize. There is a variable, customizable variable called consult omni nodes new func. And by default, if I have provided three different functions, one for org capture, one for org rom capture, and one for making new nodes with the node. In fact, if I let me see if I do customize consult omni, and if I use search for here consult omni nodes new func. So if I go here into value menu, you should see down here that there is 3 different defaults. 0 use org capture, 1 is use org roam, 2 is use the node, and 3 is you can define your own custom function. So I'm going to cancel all of this and go back. Since we don't need to do that right now. But if you use the customize functionality of Emacs, you can then see different options for some of these things that I'm providing by default. So in this case, I'm going to now change this new function to org roam capture. And if I evaluate that, and again, I'm using consult-omni node search for a novel node, it doesn't exist. When I hit enter, now you can see that this is using a org roam capture or create node functionalities. I would call this a novel nodes node, and then it opens the org capture template, and let me choose a template. Similarly, you can use one that uses create the node node. So if I do the same thing, now you can see that this is a denote create new node functionality where I can pick the title and maybe a keyword like demo, and then it will create the new node for me. And I can cancel that as well. I don't need it. All right. So that's for nodes. So you have 2 different options, either using a consult node backends for just searching the titles of the nodes or files. And if you want to search the contents of the nodes, then you can use consult-omni nodes search with some simple customization of which files you want to look to search and which backends you want to use for creating new nodes. And that's everything for nodes. Next, we're going to talk about agenda and org agenda items. Again, consult comes with consult org agenda. Let me see, consult org agenda. And when I open it, it kind of shows all the headings in org agenda files. And with consult-omni, we are making some new commands for this called consult-omni org agenda. So if I run this and let's see, maybe I search for Emacs. Yeah. So now you can see that in this case, I search and I get hits for any heading that I have in my agenda files that contain Emacs. Or I can say YouTube. And you can see there is some example task that I made. And this is not my actual org agenda items. I just made a few tasks just to showcase for this demo for Consult Omni. So there's not a lot of hits right now, but you can see that I see the title and then I see what the to-do heading here. So this is a next to-do item, and I also see what files it's coming from. So let me go back. For example, if I do Emacs, you can see that I can see some of them are to do, some of them are next, some of them are done. Maybe there is and you can also see the priority. You can also see the scheduled date, and if there is a deadline, you would also see the deadline next to this scheduled date. Now let me cancel that. Okay, we already did this. Now with consult org agenda, there is some special feature that allows you to search for things like today or tomorrow. So let me evaluate this line, and I'll come back to this agenda transform prefix customizable variable. So here, if I say consult omni org agenda today, and by the way, all of these functions, I'm running this because because I made the notes for this video, so I with specific examples. Otherwise, what you would normally be doing is you can do meta x consult omni org agenda, and then you would type today, right? So this would be what you would be doing to get these results. But since I wanted to remember every specific example, I have already prepared them in this format. Now, what I wanted to show here is that when you search for today, instead of looking for the word today, it's converting that to the date for today, and it's searching. And you can see here, this is the date that I'm doing this. July 17, 2024, and it's looking for that date. And since we already have scheduled and deadlines in these titles, it finds anything that is either scheduled for today or has a deadline for today. Now, it can be tricky if this exact date doesn't show up in, for example, in a deadline or a schedule, but so far, at least with the examples that I have here, this works pretty well. So now instead of today, I can also say tomorrow, and I see something. I can say next week, and I see everything that is within the next week. And again, it's converting this next week query to different dates and is looking for all of those dates in the agenda items to find relevant targets. Now, this is useful, but what if you want to search for the term today instead of converting it? So for this purpose, I've defined a customizable variable that I'm this consult-omni org transform prefix that I am setting it to a question mark. So let's do that. And then I'm going to run the same search that I did before with today. And you can see I made some examples that have the term today in the title. And it's finding everything that has the term today in the title. And you can see the dates are different. Some are today, some are other days. But if I want to convert to this to the date for today, I can put a question mark before, as we defined in this variable, and now it's finding only it's transforming the query to the date for today, and I can then similarly say tomorrow, or let's see, next month. Do I have anything for next month in my probably not, but I can do maybe next work week, and it transfers the query to next work week, which means Monday to Friday of next week. All right. Now there are more. You can also use the term around in your query, and that means to look. Right now, it's looking for 7 days before and after today, so it's a period of 2 weeks around today, and it shows everything that happens around today. I can also combine this with, instead of around today, I say around next week. So it takes the date exactly 1 week from now and then shows what happens around that, which means 7 days before and after. Now, of course, that 7 days is customizable. Here, for example, I can change it to 1 with this variable consult-omni org agenda number of days around. Let me cancel this. Set it to 1. And if I run this again around today, now it's only looking for 1 day before and after the term today. So it's today, tomorrow, and yesterday. And again, if I change that variable to 14, it looks for 2 weeks before and after. So now I'm looking at a search term that says around and 1 week ago. So it recognizes 1 week ago and finds the date of exactly 1 week before today, and then looks around that, meaning 14 days before and after that date, and looks for all those dates in the agenda item. So this is pretty cool for searching agenda items. Let me decrease the font size here a little bit so the table doesn't look so bad. And here is a list of everything that you can do when you're searching agenda items. You can use yesterday, today, or tomorrow. You can use this next or last week, this next or last work week, this next or last month, year. You can use terms like number of days or number of weeks ago or months or years, and number of days, weeks, months, or years from now. And you can also use here, I think I'm missing now, from now. And then you can also use around date or around one of these phrases that then gets converted to plus and minus 7 days, 14 days, whatever you set the customization to. So maybe we can try this ago one. Maybe we didn't show that. So let's say here, transfer this to 2 weeks ago. What happened here? 2 weeks ago. Something didn't work. Let me see. 2 weeks, 2 weeks from now, or 2 weeks ago. Oh, I know, because I don't have anything exactly for 2 weeks ago. So let's do around 2 weeks ago, and then I will see results. By the way, one useful thing to know about all of these consult omni sources, especially the dynamic ones, is that if you want to see everything, you can always search for dot star, which is a regex pattern that matches everything. And then by default, consult dynamic collection starts collecting after 3 characters, but you can force it by adding this pound sign here. And now I'm seeing everything. And again, these are all just example tasks that I made for this demo. I can see all the results here without searching for anything. So if you're testing the package and sometimes you see something that is not working, you can always just search for everything and make sure that you are seeing there is no issue with finding the search you're looking, because sometimes you may search for something and maybe it does not exist in your org agenda, or maybe the package is missing, because this right now works in my setup, but if you change the formatting of dates and things, then it may not work as well. And then you should file some issues on GitHub, and I can try to take a look at it. I haven't really, this works on my setup. I don't know, on other setups, it may or may not work as well, but on my setup, it's working pretty nicely, and I can find org agenda items pretty quickly with using this org agenda, consult omni org agenda. And by the way, similar to what we said for the notes, if you create if you have an item that doesn't get any hits, you can make a new one by just selecting it. And in this case, it brings up the org capture again. And if I say, okay, this is a personal task, it uses my default org capture templates, and it puts the new item up here. I can edit this capture buffer and capture it, but I'm going to cancel that for now. All right, so we saw notes, org agendas. What else? Calculators. As I showed at the beginning with Spotlight and Alfred, you have access to calculators, especially built-in calculator. Like in this case on macOS, I get results from Mac calculator. So I have similar functionality for built-in Emacs calculator. I think I already show some examples. So let me here run this consult omni calc, and if I say 2 plus 3, you will see the answer 5. Right? This is the simplest form of getting results from calculator. Now, similar to what we saw for transforming dates on phrases to dates on org agendas, we have a variable consult omni calc regex pattern. So this would be a prefix that you can use for finding for getting results from the calculator. And the reason this is useful. So let me actually pull this up again. So without any patterning. If, for example, here I say consult-omni, you see that I get some results from the calculator, even though this is not a mathematical equation. Because Emacs built-in calculator can also do parametric math, it is treating this term as consult minus omni. So in other words, if I put 2x minus x, I can get the results from the calculator with just parametric calculation. So for this reason, I have defined then this regexp pattern, which here, for example, I'm setting it up to any query that starts with the sign equal sign, and then I have a capture group for anything in this regexp pattern. Now, if this regexp pattern contains a capture group, the first capture group is used as the query. So meaning that if now I run, let me see, let me evaluate that again. If I run this, and if I say 2 plus 3, I would not get any results. But if I put the equal sign here, anything after this equal sign gets captured in this group, and that will then be treated as the query. And this is specifically useful when you're doing multi-source searches, because in a multi-source search, if I say consult omni, I probably am not interested in seeing results from the calculator, even though it doesn't really hurt. Maybe it's not as interesting to see results from calculator. So in this case, I can avoid getting results from the calculator, and when I want to get results from the calculator, I can just put an equal sign here and see the results from calculator, which shows up here. All right. By the way, if this regexp pattern does not have any capturing group, then the entire string that matches will be used as the query. So when there is no capturing group, then the entire string will be used if it matches. If there is a capturing group, the first capturing group will be used when it matches. Now, okay, of course, the good thing about using the Emacs built-in calculator is that now you can also do a lot more complex math right here in your Emacs mini buffer. So let me run this now. So here the equation I'm looking for is the integration of x squared over x from 0 to a. And the answer is a cubed divided by 3. Right. So you can see that we are solving some integrals with some parameters here like 0 to a, and we can get results. Now I can make this even more complicated by saying solve this integration equals 9 and solve that for a. So now it's solving this equation where I say the integral of x squared over x from 0 to a equals 9. Tell me what a should be. All right, so you can see that this is pretty powerful in terms of doing calculations. Of course, you still need to learn a little bit of syntax about how to deal with this in Emacs. And to do that, you can look at the function that I'm using on the back end here is calc eval. So you can look at calc eval documentation and how that works. It takes a string and returns results. But it's pretty powerful in terms of getting calculations. So this is something that you cannot do in a Spotlight or Alfred. So if you do a lot of mathematics with something like consult-omni, you will have all these quick answers right from the mini buffer when you're doing searches for anything from web searches, etc. You also have the results from the calculator. The other thing that might be interesting to think of here, by the way, this using this regexp pattern and putting the equal sign here does not change the rest of the results by much. You can still see results from Brave and GPTel. In fact, if I open the results here from GPTel, let's see if the AI chatbot can solve that equation. And let me go here. Okay, so you can see that I can still, with having this equal sign here, I can still get the exact same equation in GPTL, and it's also solving the equation for me. In this case, it's also formatting it into LaTeX format. So that might also be something you want to consider if you want to do mathematical equations. Instead of using built-in calculator, you can also use an AI chatbot. Let's see if, in fact, now I'm curious to see if this chatbot can solve the equation we had before. Let's say this equals 9 and solve for a. Okay, it's doing something and it seems like it got it right. So let me see. Yeah, so as you can see, um, the chatbot is also solving the equation, and it's also formatting it pretty nicely and showing the step-by-step calculations here. So you may or may not need the built-in calculator if you use, for example, GPTL for getting math results. That's something to consider. I think the built-in calculator can be faster and cheaper probably than using AI APIs, but in general, you can use either of them. Now, one thing, there is one more thing that I don't think GPTL can do, and we can test in a second, and that's it, passing, actually, let me put this to 0, passing variables to an equation. So here I would put a $sign instead of 9, and then using the similar syntax that we used before, I use a key with $sign, and I pass 9 to this. So here what I'm saying is that run this equation, but replace the $sign with 9. So now I get the answer for 9, and if I change it to 10, you can see the results will change here. If I do 12, something else. Let's see, if I do 72, I think we should get 6. Yeah. So that's nice, because now you also have this option of passing numbers to a variable. Oops, I wanted to test that on GPTL. Let's see, I don't think GPTL, because I don't have any definition. It's still solving the same equation without really understanding this context of replacing $sign. Now you can also, let me actually run that command again. You can also pass multiple values. So here I say $2 and $1. So instead of just one number, then I have to use a syntax like this, where I would use in quotes, I put things in parentheses, and then, so similar to an eLisp list kind of format. And then I say for $1 use still 72, and for $2 use 0. So now I am replacing both. So now I can change $2 to 2, and I will get a different answer. So you can do pretty complex math right here in the mini buffer using this consult-omni calculator. You can also, by passing variables, you can also do something like this, where you then pass eLisp function instead of just a number. So here I'm saying do the math of $1 times $2, and then replace $1 with this function, display pixel width, and the $2 with display pixel height. So I'm getting the total number of pixels on my display just using the Emacs built-in calculator and some eLisp. All right, so that's pretty powerful already. We did conversion earlier, and if you remember, I said we can come back to it because there is a way to do conversion in consult-omni calc as well. We just need a slightly different syntax, and the syntax is like this. So I would say 50. So let's first actually do 50F to C, and this won't work because Emacs calculator and the backend function that I talked about earlier, the calc eval, does not understand this string. But in order to get it to understand, we have to, first of all, we have to say degree F for degree Fahrenheit. So that's 50 degree Fahrenheit. And to convert, then we have to use a syntax that I defined as this, where I pass a variable colon C, and then I say what unit I want to convert to, and now I get 10 degrees C. This is, of course, one way of doing it. Maybe you can also use other things like GPTL to do this kind of conversion. But if none of that is interesting because you want to be able to, call the omni-search and type and get the results, then you can also use another source called Numi. I hope I'm not butchering the name. I think it's Numi. This is an interesting calculator for macOS, and I think also works on Linux. So let me actually pull up the GitHub repo first. And let me see. I think, yeah, it's this first one, beautiful calculator app. So let's open that in Firefox for a second, and we can take a look. Yeah, it's a calculator app for macOS, Linux, and Windows. It looks like this. If you have the GUI version, which you may have to pay for, then you can do all sorts of things in here, calculations, unit conversions, dealing with date and time. It also comes with a command line client, which is, so here you can see brew install and all different installation, and the command line client is numi-cli. The client does not have all the functionalities. In fact, you can see here that it does not support dates and time zone conversion, etc., but it does support unit conversion and simple math. So to use that source, you have to install, of course, the Numi CLI command line. And then if you call consult-omni Numi, so now here I can, of course, do 2 plus 3 like what we did before, and I see results from the calculator. I can also directly say 50 F to C, and it converts degrees for me. I can also say 20 USD to Euro, and it looks up the conversion rate and gives me an answer, or let's say maybe GBP. Okay, now we are changing it to pounds. Time zones don't work right now, but here, let me actually pull up the GUI. Oh, that didn't work. Let's see. Okay, here in the GUI, for example, you can see you can also do PST time. It calculates its conversions, time in some locality. You can also do math with dates, but some of these features don't work in the CLI. And since in consult-omni we are using the command line backend, we don't have all the functionalities, but hopefully over time, if Numi adds support for those functionalities in the command line backend as well, we will get it in consult-omni. So for calculator, you have basically 3 options. One is using the built-in Emacs calculator. If you install Numi, you can also use Numi, and then you also have AI chatbots like GPTL that can also do math for you. So it's up to you to pick which source fits your workflow. All right, so we have looked at notes, agenda, calculators. Now let's look at App Launcher. I already showed this earlier, demoed the functionality, but let's talk a little bit about the features here. This App Launcher source that we have in consult-omni combines different packages. There is Council Linux apps as part of, I believe, Swiper package that can then find desktop applications on Linux and shows them in the mini buffer, and you can select them and it opens them. There is the equivalent of that for macOS called Council OS X apps, also use IV Council. Then there is App Launcher that uses consult instead of counsel, but it only works for Linux apps. And then there is also this open with package that then you can use open, you can tell Emacs to open files with any applications. And for consult omni apps, for this app launcher part of the consult omni, I've combined all of these into one universal package with borrowing codes from here and there and kind of patching everything together so that it works on Linux and macOS. And you can also do some open with functionality. So let's take a look at it. This was, in fact, one of the things that was missing in Consult, at least for my workflow, that I didn't have access to because none of these really work on a macOS setup with Consult. So now this Consult Omni app should, in fact, solve all of that. So here, if I do Consult Omni apps, again, the same interface. So if I start searching Firefox, I will see apps that match here. And if it opens Firefox, let me see, I can then open a new tab if I want to. Let me minimize that. I can run this again, Visual Studio Code, and it opens VS Code. Let me quit that. Maybe Adobe. I can see all the Adobe apps here. I'm not going to open them anymore. So very simple. Just you can run consult omni apps and start searching for the program you want. Now, of course, this is not exactly the classic version of an app launcher. In classic app launcher, you usually see a list of all the available applications, and then you can narrow down. So this is one of those cases. Maybe a static function is more interesting. So, and to do this, you can run this command where you pass the regexp pattern for everything to consult omni apps static. So it collects all the available apps, and then you can do a narrow down. Like here, you can see. And you can also see the ones that I've opened recently on top and followed by the ones that are listed alphabetically. This is, of course, is done by orderless and ordering my mini buffer. Normally, you may not get this kind of ordering, but in my setup, at least I can also see the recent ones on top. And again, if you don't want the static one, you can always pass this regexp pattern for everything and force console to find results by adding the pound sign at the end, and it will have the same effect as running the static command. So it's up to you if you want to use the static command or dynamic command, or use the dynamic command, get everything, and then do the narrow down. So here, if I do Firefox, I can get the narrow down. All right, now with this consult omni apps, there come some interesting features that we can now do. One thing is, let's take a look at embark actions that I've defined here. Firefox. Okay, so I find Firefox app here, and if I call embark here, and let's do O for open, and then let me open the help here so you can see the different functions here. Right here on top, you can see that there are 3 specific commands for embark for apps, consult omni embark apps. So there is open term, open file manager, and file. Each of them do something different. So let's start with open file manager. When I do this, it uses the system default file manager, in this case the Finder on macOS, and finds the desktop application file on my computer. In this case, this is a firefox.app, which on macOS is essentially a folder, so I can right click and show package contents and see the contents here. Let me minimize that. Now, okay, I can go back here to embark, open. Then I have open term. If I do this, it opens a terminal in inside Emacs and goes to that folder. So if I do ls A here, you can see that I am in the folder that I can then go in the contents and look at the file. And the terminal, by the way, is customizable. Here I have set it to vterm, but by default it's set to eshell, or you can change it to any other terminal command that you like. Then let's go back here. I believe we have one more to look at. And the last one is find file, which essentially opens that the location of the file in find file. And here you can then again navigate in find file. And so, and then if you hit enter, it opens the application. So you have the option of finding an app and then going to the folder that contains that app, or opening the app, or opening it in find file or terminal, etc., etc. So that's nice. The other thing that comes with consult-omni is this command consult-omni open with app. So let me run this. So if I just run this interactive command, it will ask me to select a file. So I'm going to say this one, maybe logo.png. And then it asks me to choose an app using consult-omni apps to open that file with. So since this was an image file, maybe we can do preview here. And then you can see that it opens that file in preview. Now, once you have this function, you can also bind it in embark file map. In this case, I'm binding it to capital X or Shift X. So let me do that. And then you can do, so let's say I do find file. Now, normally with embark file map, you can use some command called embark file open externally or something like that. Let me actually check. Embark, yeah, embark open externally. And if I'm not mistaken, it's by default bound to X for file target. So if I am in find file and I do this, I call embark, and let me pull up the help function here. If I say X, it's bound embark open externally. Or it might be that in my setup, I did manually bind X in embark file map to embark open externally, but embark open externally comes with embark. Then what I did is I bound Shift X with to consult omni open with app. So when I am in find file, so especially for images or for things that I want to open outside Emacs, like if I want to edit an image, of course I can look at the image inside Emacs, but if I want to open this image, so what I would be, my workflow would look like something like this. So I open this file, I look at this logo.png, okay, I can see this image, but maybe I want to edit this image. If I do find file, and I go back to that image and I call embark and hit X, it opens it in the default application on the desktop for this file, which is an image file, in this case in preview in macOS. This is not that useful because I could already see the image in Emacs. What I really want to do here is I want to say, take this, Shift X, and let's say Adobe Photoshop, right? Now, if I select Adobe Photoshop, it's going to open this file in Adobe Photoshop and I can edit the file there, or maybe GIMP or some other things. Now, I don't want to open Adobe right now, so let's just say Firefox just to show the demo. You can see that it opened the file in demo, and I can open that, close that tab, and minimize the window. All right. So now you can see that you also have this open with functionality that comes in Consult Omni. This is also useful when you do Consult Omni searches with multi-source. You can then also set up the key binding in Embark to be able to open the files that you find with Consult Omni with any application that you like on your machine. All right. let's see, we are almost halfway through the sources that we have here. The next one, so maybe we can try to pick up some speed here. The next one is a dictionary, uses built-in dictionary in Emacs. Similar to what we saw with the calculator, there is a predicate function that you can use to decide whether you want to see results from a dictionary or not. So I'm going to set this to nil for now, and I'm going to call consult-omni dictionary, and let's look for a word, maybe omni, since we're talking about consult-omni. All right, now you can see I am seeing results here from dictionary. Now with dictionary, I had to do something a little bit hacky here, because by default in Vertigo, you expect to see one candidate on each line. You can have new lines in the strings with Vertigo, but it doesn't look nice if you put a string with a lot of new lines. For a vertical candidate, it does not look nice, and it's not very readable, especially for, in this case, where we're looking at definition of words. So what I did then is that I have the name of the dictionary right here on the left. So we have 3 different dictionaries returning results for this word, omnipotent. And then I have the definition from each dictionary inserted in front of them. So now if I move on these candidates, you can see that for the first one, we have maybe 2 candidates in Vertigo. Normally, this would be 2 candidates, and here it's also 2 candidates in Vertigo. But if I open them, they are bound to the same exact function. So at the end, no matter which one of these 2 first line are open, it will do the exact same thing. And the same thing for these 2 lines and these 2 lines. So you can see the definition here. And if you select any of them, you will go to the definition. So let me show you what it does when I open a preview first. So when I do a preview, it goes to a dictionary buffer with that definition right there, and it's also highlight the word that we looked for. Now, if I go here and get a preview on that, it does the exact same thing. So it doesn't really matter which one of these lines I am on. But when I go to the next line, which is a different definition from a different dictionary, I will get the results. And then on this third one, I'm going to hit enter, and something. Oh yeah, okay. So let me actually run that again. When you hit enter, it also jumps to that buffer. So here, if I do this, it jumps to this dictionary buffer and goes to that specific definition from that specific dictionary. Of course, everything else on the back end depends on the Emacs dictionary. If you add more dictionaries, list of dictionaries to the Emacs built-in dictionary, you can see results from them. Okay, so let's talk about this consult-omni dict predicate. It's again a customizable variable. Right now, I have by default a function for it that I set this to, and this function simply looks at the query and matches it against a term. So let me actually see if I can bring the help function. I mean, we can see. So as you can see, it basically checks whether the query has the word define, or in this case, or maybe capital with a capital D define before the term, and if so, then it looks for anything that follows this define and tries to find it. So that means that if I then, let me see, if I run this consult omni dictionary with omnipotent, I won't see any results. But as soon as I say define omnipotent, I would start getting results. So again, this is useful in a multi-search, in a multi-source search with consult-omni. If you don't want to get results from dictionary every time you do a search with consult-omni, but you want to have the ability to get results from dictionary whenever you want, you can do this, run a consult-omni search, and if you decide that you want to see the results from dictionary, you just add define in front of the word and you can get results. The other thing is that you can also, there is another customizable variable here, consult-omni dict number of lines. which if I set this to nil, and then I run this same command and ask define omnipotent, now you can see that I see the whole definition from the dictionary. As I said, since with Vertigo, every line is a different candidate, it's not, if you do this, then moving to the next candidate is not that easy, especially in a multi-source search. You may have to move over many lines to get to candidates from other sources, for example. So for that reason, my preference is to limit the number of lines to one. So I see one candidate per line. So when I do this, now I have per line, I have one candidate, each from a different dictionary maybe. And if I want to see the full definition, of course, I can always use the preview or select that candidate and jump to the dictionary. One last thing on the dictionary is if you type in a word that doesn't really match, the dictionary can still get suggestions. So for example, here I say define nove, N-O-V-E, and you can see that there are, it does not show any really definitions. It's suggesting some words. So let's see, maybe this first dictionary G side, and if when I get the preview, or in fact, actually, let's select this. Now you can see it jumps to the dictionary buffer. I can see there are matches from G side, and then if I enter on any of these, I can see the definition. Maybe I meant note, not nav, and I can get the answers. So this is really useful, especially if, for example, if I do this, um, I can see suggestions right here in the mini buffer, or if I do the preview, I can see suggestions. So then I can correct. Maybe I forget how to spell a word. I can do this. I see suggestions from dictionary, and then I go back and correct the spelling. All right. So that's dictionary. The next source we should talk about is Invidious. This is essentially a third-party YouTube search server that uses I believe version 1 of YouTube API. YouTube recently switched to version 3, I believe, but Invidious is still using an older version, but it's free, and unlike YouTube, there is not a lot of limits on search terms, etc. So especially with YouTube, I do have a source for directly using YouTube API, and I showed it in my previous video with Consult Web, but I was hitting the limit a lot when using that API, because every time you do a search, it uses, I don't know, 100 tokens or something, and there is a very limited number of tokens you can use per day, I believe, or maybe per month. So with YouTube, I was hitting the limit a lot. So now with this, with using Immediate, I don't have to worry about the limits. The looks are a little bit different if you use Immediate versus YouTube. So let me run this, and then I can search for Consult Web. Maybe we see some of my own videos from last time. And in fact, yeah, this is the video from last time. So you can see, I see the video, the date, the channel or the user, the length of the video, and you can also see number of views, etc. Here, of course, let me do this. So maybe, or not apps. So you can see the number of views and etc. Sorry, scrolling there doesn't work as well. You can see number of views and durations, etc. on Immediate. If you do, let's see, console omni YouTube, consult web. So you can use the YouTube source directly using YouTube API. Here you can also get results for channels and playlists, as you see here. And then for channels, you see number of subscribers. For playlists, you see number of videos in that playlist, etc., etc. If you select them, it jumps to the browser and opens them, or you can open them inside Emacs. Those are all customizable from within consult-omni package. There are different commands for what to do when you open or select a YouTube or NVIDIA's function. I don't go into more details on NVIDIA's. I think you can just try it and see it for yourself. Other than that, well, I think Alfred worth another mentioning, even though I showed this in my consult web video, because Alfred can also cover a lot of other things. For example, if you use the package called Alfred Tube, I believe, let's see. Yeah, Alfred Tube by Clarthink. Let's just get the preview here. If you use Alfred Tube, you can subscribe to YouTube feeds on Alfred. And then when you use consult-omni Alfred, you can get results from your YouTube subscriptions. So this is essentially a workaround for searching your own YouTube subscriptions using consult-omni. So if here, for example, if I do search Emacs, I see here results from my YouTube subscriptions, which I've done using Alfred Tube. So for example, I can see videos from System Crafters, and if I open this, I can see a link to this video. There's even functions within Alfred Tube to watch this link with MPV, for example, etc. So there are other sources that are not directly right now in consult-omni, but using Alfred, you can also search them, like YouTube subscriptions, maybe Reddit. You can also get results from Reddit by using Alfred feeds. One more source here, browser history, and I'm getting a little bit tired here, sorry. And I say experimental here because it's a little bit buggy, so let me see if it works now. If I first, it uses this package browser hist search. So if I do that, okay, now it's working fine right now. So it uses this browser hist search as the backend. So I can then run consult omni browser history, and let's see, maybe if I say consult, okay, it's something. I think I was doing some testing, so it's printing something. I have to go get rid of that print command in the function in preparation for the video. I was testing this, but now you can see that I can also get results from my browser history in consult omni. This is also useful as a source to have in your omni-search, maybe to see previous browser history, which is not easily available in other search tools like a Spotlight and Alfred, but here you can get it using this browser history. As I say, it's a little bit buggy, and the reason it's buggy is because it's using database files that are stored on your local machine by browsers, but sometimes those databases are locked or there are permission issues, or when the browsers update, they change the structure in the database, the data structure in the database, and then a browser history start failing. So right now it's working for Firefox in my setup, but sometimes if I open Firefox or close it or do other things to it, maybe that file is not accessible by Emacs anymore. So that's something that I intend to look a little bit further into. Maybe we change the backend from this browser hist to something else, but I have to see if what are the options and whether it's possible or not. But for now, I think this is good enough for also having a browser history search in consult omni. List of all current sources. As I said, the list of all current sources is available on the GitHub README. So let me just quickly, or actually, let me just open the local version. Might be, oh, not there, maybe here. List of sources provided by default. Here is a full list of everything. The things that I didn't talk about, mainly because I've talked about it previously in Consult Web, are some of the web search engines like Brave, Bing, Google, DuckDuckGo, etc. There is, and also some other Emacs utilities like searching buffers in Emacs. Or searching projects in Emacs, those are also available. We have a Stack Overflow, PubMed, etc. So you can just check, and also the auto suggest commands for Google and Brave, where you can just type a word and get auto suggest from Google or Brave. Let me go back to the show notes here. Maybe I can make this a little bit bigger again. All right. So as you can see, there is a lot of new sources, a lot of new utilities, and it's really up to you how to combine these different sources in your workflow using consult-omni to find the results that you want. I will keep adding maybe more, or adding small features in terms of embark actions, or what happens when you have a new candidate versus opening old candidates, etc. But for now, I think we already have a lot, and it's already way more powerful than most other omni search tools like Spotlight and etc. You cannot really do as much as you can do here, especially when it comes to customization and fitting everything to your own workflow. But that said, you can also extend the sources. I'm going to come back to that at the end of the video, since this is already getting long and most people are probably not interested in adding their own sources. But if you are a power user, stick around. I'm going to come back to how to then extend sources. So with that, we finish covering all the new sources and some of the interesting, most of the new interesting features. There are maybe two more things to talk about in terms of features. These actions are new items that I already showed with notes that you can use org capture to create new notes. With org agenda also uses org capture to capture a new task maybe. We also have this now for search engines. Like if I do in Brave, if I say Emacs, I will get a bunch of results here, of course, but I can always go back to the mini buffer and select this prompt, and it will jump to the browser and opens the Brave search page with the search term Emacs for me. You could also do this with some embark action and calling embark action to open the search URL, but now you can directly do this with new items. Actually, let me close this and minimize that. And then if I run consult-omni Bing and do the exact same thing, it then opens the Bing search with that term. By the way, notice that when I run this, even before I get results, if I don't want to wait, so here I can type Emacs and enter. Even before getting results, I can just end that command and jump to the results if that's what I want to do. So sometimes if you're impatient and you don't want to wait for the results to see inside Emacs, you can always just jump to the browser like that. This is specifically useful for DuckDuckGo because the DuckDuckGo API implementation right now in consult-omni is not really that useful. It just gives you links to some suggestions for the term you use. For example, here if I search for Emacs, instead of giving me direct results on Emacs, it gives me links to DuckDuckGo searches for terms that may be relevant to Emacs. But I can, of course, hit enter here and then open DuckDuckGo with that search term. And then similarly, when you run consult omni multi, if I search for Emacs, I get a bunch of results, of course, but I can go back here and hit enter, and it asks me which search engine I want to use, because now that we are in a multi-source settings, which search engine I want to use to search for that term. It also includes GPTel here. Maybe I would say, okay, let's use Perplexity, and it will open a Perplexity web page with the search term Emacs for me. Now, if you don't want to search to select a search engine, you just want to set it and be done with that for future multi-source searches, then there is a customizable variable for default search engine, which I can set to Perplexity now. And if I run this and hit enter, it directly jumps to Perplexity. So you also have a quick jump to the web browser if you're not interested in any of the results that you're seeing in your mini buffer candidate list, or if you don't want to wait for the results and you just want to directly go to the web page source, or even in GPTel. By the way, you can also add more sources to the default search engine list. Let me see, consult omni-search. Search engine, consult omni search engine A list. This is an A list that defines the name, and then either a string that would be a URL where you would have this kind of formatting function where %s is where the query term goes. Or, for example, in terms of GPTel, you would then have a function like consult omni GPTel preview that gets past the string of the query to run. So you can add any other function here and use that as your default search engine as well, or you get the chance to select any of these when you don't set the default search engine. The other thing to mention is the narrowing function, because narrowing works really nicely now. We did show this before with consult Spotlight style, so I won't spend too much time on this, but just quickly, if here I use meta O, which is what I bind to consult narrow, I get a list of results, list of sources, and then I can see B, and then it says it narrows the results to Brave. So now if I search for Emacs, I will only see results from Brave. And if I change this term, it's as if I ran consult omni Brave. And then if I go back meta O and I hit meta O again to get all, I don't see immediate update, but if I run the command again, now I will again get results from all the sources. And as I said before, you can let bind the split style with comma, and then you can just type one character and a space and get narrowed down, similar to other consult commands. So in a way, you can also use consult omni as a starting point. And then if you decide that you just are interested in Brave or Google or Wikipedia or GPTel or something else, then do a quick narrow down to get that, instead of thinking about which command from consult omni you want to run. So that's another way of thinking about your workflow, that you always start with the multi-source search and then you do the narrow down if you want to. All right, so that's done with sources and features. The next part, we're going to talk about some tips and configuration and how to on installation, etc. So let me just quickly grab some water and come back for the next part. All right, I'm back, and now we're going to look at tips for installation and configuration. If you look at the README I have, let me open this link. I have drop-in example for config, there are different examples. One just for a minimal config, maybe to just load Wikipedia, and I see maybe there is some typos here that I need to go fix. But there is some drop-in examples for minimal config, and then some for a reasonable config with mostly default settings. And then there is also one for advanced users with lots of configuration and adding different new commands and things for those of you that want to change some of the settings and kind of make it fit your own workflow. This might be useful to see this more advanced config. So you can look at that and use it for your configuration. But just to give you a little bit more context, let's talk about how you can go about doing the configuration. First thing first, my recommendation would be do not load all the sources, all the features in consult-omni. There is a lot, and some of them may not be work on your setup. Try to start small with maybe one or two sources that you are interested in. And to do that, you can always have in your configuration, you can set this variable consult-omni sources modules to load, and then you can pass you can set this to a list of the modules you want to load, and the modules are named like this, and here is the same typo. Let me fix that. It's named like this, consult-omni dash the name of the module. So it can be consult-omni Wikipedia, Brave, Google, etc. And you can see all of them on the repo. So if I go here, you see there is a folder called sources in that repo, and every one of them, every one of these elist files is a module. So you can load any of them, and with each of them you will get a new source like Wikipedia or Brave, etc. So you set this variable, and then you call consult-omni sources load modules. If this variable is set to nil, by default, it will load all the modules. If you set it to a specific list, it will only load that list. All right, so that's the first thing. Make sure you load the sources that you're interested in, especially because each source may have its own requirements. If you're gonna load consult-omni not much, it depends on the Emacs not much package. And if you don't have the not much package, or if there is some issues with the not much package in your Emacs, you are probably gonna see issues with consult-omni as well. And sometimes it may even prevent your init file and configuration to continue loading things, because it depends on some of these other settings, and it tries to load them and it fails. So it's important to understand that whenever you're loading a new source, it's essentially similar to installing a new Emacs package, and it has its own requirements, its own settings, and to use it, you got to make sure that those settings are in place. If you do if you want to use, for example, consult-omni new me module, this would require the new me CLI package. If that's not installed on your machine, you're going to see some issues and failures. If you're going to use consult-omni Brave, you need to have an API key. So after you load the consult-omni Brave, you need to add some configuration and setting to set the API key for the Brave API. Without it, it's going to fail. So whenever you add a new source, you need to understand what are the requirements, what are the settings that you need to have. This is not something that we can fix in consult-omni. This is part of how a tool like this works. If you need to use an API, you need the API key. We cannot bypass that. Each source, there is a different set of customization variables which you can look in those elist files. Right now, not everything is in the README. I am hoping to add more manuals over time, but for each source, you have to kind of look at the source file and kind of understand what are the customization, or call the customize command on Emacs and look at the variables that you have and what you can set, etc. And in this video, I've shown already a bunch of variables and features that you can set for different sources. So that's about setting things up. And of course, always you can file issues, post comments, start discussions on GitHub, and I try to be responsive as much as possible on those things. By the way, one more comment on installation. If you do lazy loading, like something like what that you would be commonly doing in Doom, Emacs, etc., you need to understand how the lazy loading works and what package is getting loaded before what package, what other package, because in this case with consult-omni, when you load a new source, you depend on a bunch of other requirements, and those things should be in place when some of the commands are being defined, because we are also using some macros here, and the order of what gets loaded needs to be right, otherwise things can fail. So if you do lazy loading, you have to spend some time, and if you see issues, you have to then spend some time understanding how the lazy loading order of things are working in your configuration, and fix it for Consult Omni to work as intended. Next thing that I would recommend to think about is defining new commands, as I showed earlier. For example, defining some interactive command with a specific set of sources like consult omni scholar, consult omni web, local, Emacs, etc., so that you don't have to always send the query to every possible source. It makes sense to try to break things apart a little bit, and there are cases where you're only interested in local files. There are cases where you're only interested in a web search. So you may want to define a specific interactive commands using this consult omni multi function, and then use the specific commands instead of having one big one command with all the possible sources, because one, it can be slow when you have many different sources, especially if every one of them return many hits. Two, some of these sources will have rate limits with APIs, like as I talked about YouTube, for example, earlier. So you may not want to keep hitting those servers with searches that are not meaningful for them. Uh, so try to be aware of what happens under the hood when you're using some of these consult omni sources and you're running searches. Because we are using APIs, you may end up hitting rate limits. Some APIs are not even free. Like, for example, if you're using OpenAI API for AI prompts, you may be paying for it. So be aware of that and try to find the right workflow for you that works without hitting rate limits, without spending a lot of money, etc. The next thing that I think would be useful to think of is that you can also then define some commands around the utilities that you have seen. For example, one thing that I do in my own configuration is this auto suggest at point function that I define. So I can show you here. I define something to pick the thing at point, and then look for maybe in this case a Brave auto suggest for it. And then down here, let me see if I have I don't have it there. Okay. In my setup, I then bind this command to some meaningful keys. So I think in my setup, so let's put some words here so we can use it. In my setup, super tab, or the Windows button tab, or on macOS it's option tab, is bound to completion at point. So if I do this, I can see completion for what is at point. Then what I do is I bind super or option shift tab to this auto suggest at point. Oh, wait a second, that didn't work. Okay, for some reason that key binding is not working right now. So let me Let me quickly jump into my config and see if maybe it didn't get saved last time when I did not find it. It must be here. All right, so if I evaluate this line here in my config, which for some reason did not is not running right now. So if I now do that, okay, now you can see that I'm getting the auto suggest command at point, and I'm getting auto suggestions from Brave. This then also works in mini buffer. So in mini buffer, I also set up my keys and key bindings in a way that I can then quickly do things. For example, in my setup, I have meta keys bound to things for changing sources and queries in consult-omni. So let me open consult-omni multi. So here, for example, when a starting point, meta n and p are bound to previous and next history. So you can see I can quickly do meta n and p to go back in the history, and next elements are usually bound to things that are at point. That comes with consult omni, that picks up things that are at point and puts it in your future history essentially. So you can use meta n to find. So in this case, since I was on m dash, it's picking what m dash and puts that in the search term here. And then so I can use meta n and p to go back and forth in history. Then I can use meta o for narrowing. So for example, here maybe I can select Brave, and if I want to go back, I could just hit meta o again. I have meta I, which is essentially tab for completion, if I want to do completion here. And then I have meta u for Brave auto suggest that point. So quickly I can find the right query for my command. And then when I do have the command and I get the results, I have C keys or control keys, or in macOS maybe command keys, etc., to move over. So I can use control J and K to go up and down, control L to pick, etc. So I can use control keys for moving over the candidates. Embark, I also have control, I think, dot bound to embark. So then when I have the candidates, I hold control, and then I can move over the candidates and use that and call embark. And then S keys are again bound to completion, either within mini buffer or outside mini buffer. I can use that as well. So think about how you design your key bindings as well in when you use consult omni, so then you can quickly pick the right sources or narrow down or find the right history in element, and then move over candidates and do the selection. All right, so that's all for tips for configuration. I'm sure you're going to have more questions and issues when you start testing this package, so feel free to contact me either through emails or on GitHub or on YouTube, etc., and we can take a look at those together. The next thing that I want to talk about, and things are going to get interesting, is desktop integration. This is what I showed at the beginning, where I can pull up an Emacs frame that is designed to be a omni-search tool. So let's look at how I did this. Normally for my own setup, I'm using this package called Yequek. By Alpha Papa, which are designed for making Emacs frames. So here you can see provides configurable drop-down Emacs frames similar to drop-down terminal Windows program like Aquake. So this is useful for making a one-of frames that you want for a specific functions. I use this in my own config, but to just give you a simpler example that kind of does what Aquake provides. Maybe Aquake has more features, but this is a simpler version. What I'm doing is essentially defining a bunch of parameters to pass to make frame, so width, height, left and top, and I'm trying to calculate based on the display width and height. So maybe I want something centered, and maybe 60% of the height and width of the display. So I get those variables, and then I am defining an A list for parameters to pass to make frame. I give it a name like demo omni in this case, width and height, left, top. And then importantly, I say mini buffer. I pass T to mini buffer, so that it means that this frame gets its own mini buffer. And then I can just then call make frame with those parameters. And then I select this frame, I put the input focus on in this frame, and then I just called consult-omni multi. All right, so let's evaluate this. And here I would say consult-omni. Let me see, what did we call it? Demo omni. Demo omni. So if I run this, you can see it makes a new frame here, puts it in the puts the cursor in the mini buffer, and if I search Emacs, I can get the results. And then I can, when I'm done, I can close that frame. Now, that's very simple. Of course, what I showed at the beginning, you can also make a simple dashboard for it. So you do the same thing with making frame, and then within the when you select the frame, you can put the input in there, and then you just make a new buffer, put some text in the buffer, and then maybe center the text. You can also add an image here. I've commented this out. So let's just run this now. It just makes a buffer and put some text in the buffer, maybe things that might be useful, and then some code to center those lines and kind of makes things look nice. And then at the end, again, I run consult multi omni. So I do this and I run the same thing. Now you can see that I have a buffer with maybe a code from Rumi here, and then some quick reminders for the keys that I already talked about for doing things. And then if I do Emacs, I get search results here, and then I can use the keys here to move around and get things, especially, for example, for preview. I have the reminder here that in my setup, Command O or Control O is bound to preview. So if I want to see preview, it reminds me how to do that. All right, let me close this now. Now, of course, if you want then to be able to call this from anywhere on your machine, not just from within Emacs, then you're going to need to run the Emacs as a server and use Emacs client, which I can try to do here. Let's see, hopefully it doesn't break things. Emacs client, and I call this a specific server that I have here, main Emacs. You may not need this s variable here. And then I just evaluate this command that I was running inside Emacs. So when I do that, you see that it opens the a frame, puts the cursor in there, and I can search Emacs. And this is essentially what I was using earlier to call my omni-search tool. So it's pretty easy if you use the Emacs server in the background. It's pretty easy to then integrate everything with your desktop, and then call the search the omni-search tool. Similarly for the launcher, you can do the exact same thing. You define some parameters for the frame. The key thing here is that I say mini buffer only. So then for the launcher, I probably don't need a preview area. So I just want it to be a mini buffer only. So let's evaluate that. And if I call consult-omni demo launcher, you see I get this frame with the list of the apps, and then I can just do what I was doing earlier. Importantly, I do this I use this on Win Protect here that says when I'm done with the mini buffer, so when this consult omni apps static is done, so it runs this command here, this function here, and once it's done, no matter what happens, whether there is an issue, an error, or something else, it will run this other command, which essentially deletes the frame. This is really useful for a launcher, because in the launcher, once you're done, if you select the app you want, you don't want that Emacs frame to stick around, so you want that frame to get deleted. And in this case, that's what this part of the code achieves. So I will put these show notes on the YouTube, so you can take a look at it and use these codes also as well for desktop integration. You just need to have the Emacs server in the background. If you then want to be able to run this with some key binding anywhere from your desktop, you just have to run the Emacs client script and evaluate this command. In fact, while we are talking about the desktop integration, you can see here I am inside a macOS environment, but I have some custom bar up here called sketchy bar, which we can also look at that repo on GitHub. Yeah, this first one from Flix Kratz. It's a customizable bar for macOS, and I'm also using a window manager on macOS called Yabai. Let's see if I can also find here this first one, a tiling window manager for macOS. I'm also using a tiling Yabai tiling manager on macOS. So not only I have these commands that then I can call with key bindings from my desktop. Also in my bar, I have this search button that if I hit, it opens my omni-search frame as we saw earlier. I have one that opens a GPTel buffer, which I also have bound to a gesture that on my trackpad, so I can quickly do this, and it opens this GPTel buffer on the so when I drag from the right side of the trackpad, it opens it, and I can do this again and it closes it, so I can quickly access this GPTel buffer. Tell me about Emacs. So I can quickly chat with my AI assistant, so to say, on my machine. And when I do it, it goes back again, opens that same frame, so I can also keep a record of my chat here. I also have this Emacs button here on this on the bar, where I can see the number of new emails I have in my Mu4e inbox. I have a button for org capture. When I do this, it opens this org capture, so I can quickly capture things from anywhere on the desktop, etc., etc. So once you start implementing these tools and integrating it, running Emacs server and integrating things, it really makes sense to then integrate a lot more of these Emacs functionality into your desktop and bring more of the things into this ecosystem of Emacs, where you are taking notes, reading things within Emacs, maybe managing your tasks, reading your emails, etc. within Emacs, and then it becomes a really super efficient workflow using Emacs. All right, all good. Now we also saw some desktop integration. Now let's talk about the part where really power users come in and say, hey, I want to add my own source and I want to define a new source. How do I do this? All right, so let's start with just showing you some examples of how you can do this. There is a macro in consult-omni called consult-omni define source that you can use to define new sources. The simplest thing you can do is here I said consult-omni define source. It needs a name, demo. It needs a type, which I'm saying sync for now. This can be sync or dynamic or async. We'll talk about what those other things mean, but for now, let's just go with type sync, means synchronous, and then request. You need a request function that essentially fetches the results and gives these results to the source. All right. So I'm going to evaluate this. When I evaluate this, it's going to make a function, a new command called consult-omni demo. And you can see now I have consult-omni demo and down here consult-omni demo static. So it made those commands for me by just running this. And it's saying that when I run the commands, it's going to use this function to collect results. So now let's talk about defining this function. So the simplest thing you can do for a collector function to get list of candidates is just to return a list of candidates. So here, for example, I am running, I am returning the buffer name for every buffer in the buffer list. So I'm running just mapcar, get the buffer name for every buffer list. Remember, this list has to be a list of strings for the consult to work, because the strings is what then gets added to the mini buffer candidates. So if I evaluate this now, so now I have defined this collector function and I have defined this source. So if I run then consult omni demo, what I get, and you see here, there is a dynamic completion interface. So if I start searching, it will run this search against this list and shows me what matches. So if I do, since we are here, if I do show note, so here is all the different buffers. Oh, actually, I was wrong. I forgot. So one thing that I did not do here is in this collector function, I am just returning the name of every buffer that is available, right? So in a sense, it's not even using the search term I'm putting here. I can here say test, and it will always return the full list of buffers. So buffer name for all the buffers available, no matter what I put here. And that's because this collection function right now does not use the input from the user. It just returns the names of all the buffers, no matter what the input. Even though the interface is still, because the interface in consult is defined in a way that you always have to give it a search term before it can returns the candidates. This is because for an omni-search tool, that's what you want. You want to give it a search term before you see the results. You don't want the results to get populated before you have the search term. All right. So let's change that. Let's just add some input matching. So now I'm redefining this function. It takes an input. All right, and this input is what comes from the mini buffer input from the user. So now I say again, go over all the buffers in the buffer list, and instead of just returning the name of the buffer, check if the string matches the input from the user. And in this case, the pattern I am defining is essentially a regexp pattern that looks for the name of the buffer, and before and after that we have some pattern that matches anything. So whatever the user puts in the mini buffer prompt, if that matches against the buffer name, it should be returned. So now if I evaluate this and run that same command, now if I say show note, I see only the buffer that matches this input show note. And if I say scratch, I probably have a scratch buffer. Oh, I have many scratch buffers in different frames that I have opened because I'm running a server and it's also looking for frames that are in the background. All right. Okay, that's good. But here, note that there is not much of formatting. It's just showing me the name here, right? So now you may want to add some formatting, which is what I'm doing here. Now, I'm redefining that function. I say, go over the buffer list, check if the name matches, and if the name matches, then instead of just returning a simple string of the buffer name, maybe let's add some text properties to it. So here you can see I'm adding simply some faces, and not only I return the name, I also return the major mode of the buffer, and at the end I am returning a string that is name, tab, mode, and name and mode also have their own faces. So let's run this, do that, and do show note. Now you can see that I get the name of the buffer, and also I see the major mode. If I do scratch, I should see a bunch of fundamental modes and Lisp interaction modes. Actually, Lisp interaction modes, because that's what the scratch buffer is. Maybe if I run consult, I would also see some helpful mode, fundamental mode, etc. All right. All right, good. So now you have a list of candidates. We did some formatting. The next thing we need to think about is what happens when you select. So it's callback actions. When you select those candidates. Again, I can first thing that I would do is I redefine this function. Everything is exactly as what we did before, but at the end, instead of just returning a string with name and mode, now I have name and mode, and I am also adding some text properties. In this case, I will define a source, so a text property with the keyword source as demo. This is critical because when I add this text property source demo to the candidate, then when I want to run a callback action, consult-omni will go look in an A list that defines all holds all the sources that are available, and for each of them there is a callback action, there is a new action, there is preview action, etc. So it goes, finds the right callback action for this type of source, for the demo source, and then passes the candidate to that callback action. So this is critical to have a text property with the keyword source for each candidate. Then I also add other information and data to these things. So I say, let's also add a buffer to these text properties, a mode, and also a path. So let's see how I define the dir here is that I'm taking the default directory in that buffer and passing it to the text property called dir here. All right. So if I run this, so now each candidate comes with some text properties that essentially carries data about what this candidate is. It's a candidate of type demo, what buffer it has, what mode it has, what dir, etc. Then I can define a callback action, and when the candidates that I select gets passed to this callback action, I simply look up the text properties that I have, for example, buffer in this case, and then I say do a switch buffer to that buffer. Okay. Now you can also, instead of doing switch to buffer, you can also use maybe, I don't know, consult buffer action, etc., etc. So it's up to you to define what is the callback action that fits best. Some of these predefined consult functions have better handling of error and performance, etc. So you can look into what makes sense in for your new source. But here simply I say take the candidate, find the buffer that we added as text property to the candidate, and then switch to buffer. All right. So now I have to then redefine the source as well. So actually, let me make sure I evaluated both of these. So now we go back to this macro that we used to define the source. Everything is the same. Demo type is sync. Request is still that same function. We just added a new key value here, which says on callback, call this function, which we just defined. So it takes the candidate, passes it to this callback function, and it should do what we expect. So let's see if I do this and scratch. Yeah, scratch. So I see a bunch of different buffers for a scratch with the Lisp interaction mode. I can also see the default directory path in them. And I'm going to select this last one. I think this is the one, the scratch buffer in this frame. And you see it switched to that buffer. Okay. How about preview? Same idea applies to preview. Now I can define a preview function. The candidate gets passed. Again, I look up the buffer from that candidate, and I use this built-in function in consult that then I say preview that. So I use funcall. The results of this consult buffer preview that creates a new function on the fly, and then I pass the preview and buffer to it. Redefine the source again. Here I add the on preview keyword with the new preview function that we defined. And importantly, I would also add the lookup and a preview key. All right. Now the preview key you can skip if you define the general preview key for consult-omni. I believe that should get used. But if you want to have a different preview key for this type of source, then you can also use it here. I am adding it here just for example. The lookup function also, you can use this built-in lookup function here. The lookup function helps retrieve some of the information that does not come with the text properties, because with completing read in Emacs, you usually lose some of the information that comes with the candidate. And with this lookup function, we try to retrieve back some of the information, especially like if you have plist and etc. I won't get into the details of that. You can just have this lookup function, or if you skip it, consult-omni by default would probably, I think, uses the default lookup function that I've defined here. But I can run this now here, and if I do this and then again a scratch, now I can go on here and use my preview key, which I defined as command O actually, and that failed. Let me see. Oh, maybe because we didn't evaluate this preview function. Yeah. All right. So now you can see that the preview is also working. I can see this as a preview. And when I cancel, I go back to where I started. That's the nice thing about having previews in Consult. All right. Great. How about new items? If you want to add another function that handles new items. Again, you can define a function here. So I define consult-omni demo new. The sand will get, or the candidate gets passed to this function. In this case, with the new candidates, you usually don't have text properties. You just get the string from the mini buffer prompt. So in this case, since the buffer may not exist, or most likely doesn't exist, otherwise it should find the function that we are using should find that buffer. Then instead of just switching to that buffer, we want to use get buffer create, so to make a new buffer with this name, and then switch to that buffer. Okay, so I kind of evaluate that, and then I pass that function to the keyword on new. So everything else is the same. I just do on new, and let me see if I say new. Okay, there is no buffer with the name new, and when I hit enter, it makes a buffer called new and switch to it. Okay, let me kill this buffer. We don't need it. Okay, so that's pretty good. We already saw how to get a list of candidates, so a collector function, then adding preview and callback functions to it, adding some function that handles new candidates or that are not pre-existing, and then also preview key and lookup. Now let's go back a little bit and talk about a more general case, also discuss a little bit about this type, sync or dynamic, etc. So in a general case, what I would normally do when I want to make a new source is I have a section to define new variables, maybe the necessary variables for API keys, maybe some customization, etc. Then I define another section for helper functions, maybe previews, maybe formatting, maybe callbacks, similar to what we already saw. Then I define a collector function. This collector function is essentially the core of this source. It's the one that has to get the input from the user and finds the hits and the search results for this input. So it has different parts. The first part is just parsing the input from the user. Maybe there are some variables passed for counts, for page, etc. Then there is the part where we take the search term of the user input and we want to get results for it. Maybe we want to make an HTTP request to get results. Maybe we want to run some eList function within Emacs to get results, etc. Maybe if you're, I don't know, using something like GPTel, maybe you want to set up models and backends and for AI prompts, etc. If you're looking at Alfred, maybe you want to run some filters to get the Alfred results, etc., etc. And then we will run an eList function applying all these different parameters that we already parsed from the user. We will run an eList function that returns the list of candidates, so the list of strings, and we want to format them as well. So maybe then in this eList function, we're going to use some formatter that we defined up here in the helper functions to also format each string. Now there are different types of collecting candidates. You can do it in a synchronous source, dynamic source, or async source. That then now we're going to talk about what each of those means. And this is what you get. You pass to the source as type sync, dynamic, or async. So let's understand what does that mean. It essentially defines for consult-omni how to do the collection. In a sync source, the collection is simply a function. So the request function is essentially an eList function that returns a simple list. All right. So for example, if I say let I do some let binding, I say make a variable called result here, and then set this result to just the name of all the buffer list, right? So if I evaluate this, I get a list of the names of all the buffer. So this is what we used earlier, for example, as a function to get the name of all the buffers. Now, if you want to do some regsp matching like what we did, you can also do within this function that does it and returns only the names that match. And if you want to add formatting, you also do this. This can all be just a simple synchronous source. Okay, now what is a dynamic source then? A dynamic source is about how we do the collection and how we can achieve collection from sources, for example, like when you want to do an HTTP request. So let's take a look at URL retrieve. So this is built-in Emacs function for getting URLs and resolving HTTP URLs, for example. So here we have a command, built-in command URL retrieve synchronously. So if I run this against this URL, which essentially searches Wikipedia for the term Emacs, and it takes some time, and then you see it returns the name of a buffer. And if I go to this buffer with 179982, you see that it retrieved the response from Wikipedia API and put the results here. All right, so this is the results that if you do something like curl or wget or etc. in command line and try to resolve that URL, this is what you get. Okay, let me now go back here. So this function returned the name of that buffer, but that's not what we really want when we are trying to get the results from Wikipedia. We want the content itself. So one way to do this is then you define a let bound variable called result, and then you say do, and I'm also defining this URL here, and then I say do this, run this function URL retrieve synchronously with that URL. It returns the buffer, and then I say go to that buffer, get the whole contents of the buffer with buffer string, set the result to that, and return it. So if I run this, now I should down here see the whole response, the HTTP response, when I search Wikipedia API for the query Emacs. All right. Okay, so this is the simplest way you can get some search results from Wikipedia. Now you can, of course, parse this response, only get the part of the response that is interesting, not the header, just the body, then break it into different candidates and format it, etc., etc. That would be a good collector function, except that all of this would be running synchronously because that's what we are doing with this URL retrieve synchronously, right? It's blocking the Emacs process for this HTTP request, but that's probably not what we want. We want to do this asynchronously, which means run this fetching of the HTTP response in the background without blocking, and when the results arrive, then show it in the mini buffer. So let's see how that would work. So there is another command, built-in function URL retrieve in Emacs that does the that gets the HTTP response from this URL asynchronously. Asynchronously, meaning that it doesn't really block the Emacs process. It just runs this in the background. Once it gets the response, it returns it. So let's do the exact same thing that we did before with URL retrieve synchronously. So I say take this URL, resolve, go do the response, and then set the result to buffer string. Now the syntax is a little bit different here. It instead of using the with current buffer type that we did before with URL retrieve synchronously here, you can directly run a function, pass a function, a callback function to this URL retrieve function that is run in the buffer, similar to what we did here. So in this case, I say just set result to the buffer string in that buffer. The issue here is because it is running this function asynchronously, it exits this command right away, and it returns the result. But because the HTTP request takes some time to get the result, it hasn't been, it's not done yet. And because it's not done, it does not evaluate this function that then sets results to the buffer string. All right. So when I run this, I just get nil because I defined result as nil. So let's just to show you that is the case here. After this function, I just say wait for 1 second. All right. Now, if I wait for 1 second, this HTTP request probably gets resolved. The answer comes in the buffer, which means then this function gets evaluated within this 1 second. And when this gets evaluated, the results will change to this buffer string. So therefore, when I then return results, I should see the content. And as you can see, that's what happens here. All right, so just this adding this waiting time here gives enough time to this asynchronous URL retrieve to get the response, and as a result, this function gets evaluated, which then changes the results to the response from Wikipedia API. Now, of course, in reality, you probably don't want to do this wait for 1 second because maybe that's too long. So you can just run a timer. In this case, I'm running a timer for 30 seconds. And I say if after 30 seconds, we don't have a result, then say, okay, this timed out. But if within this 30 seconds, the result changes, so I am running a condition for while not result. So if result is not nil anymore, or while result is nil, wait for 5.05 seconds. All right. So that means that this line here would say keep waiting for small steps, 0.05 seconds, and keep checking if the results got changed. As soon as the results got changed, it exits this while loop, and then it returns the result. So if I run this, you see that I get the same response back, but it's much faster than waiting for 1 second up here. So this is a simpler version of what the URL retrieve synchronously is doing. In the case of URL retrieve synchronously that we used up here, it's instead of just checking whether result is nil or not nil, which is not a good condition here, it's looking at what gets returned from the process of retrieving the HTTP response. So if it gets the response from this URL, it sends a signal that hey, I'm done, and then it exits the essentially the timeout loop. But the end result is more or less the same. You will get the results within some time once the HTTP response gets resolved. Now, in our case, when we want to do some search, web searches, we want to hit some APIs, get the results. What we want to do is instead of this function here that sets the results here, we want to say, take that results and add it to the mini buffer candidates list, right? And we probably want to do this with multiple APIs, multiple servers, one for Wikipedia, one for Google. And with every one of them, we want to then spawn a new process that retrieves those URLs in a buffer. I keep clicking on these URLs. In a buffer, go retrieve the results, and when the results arrive, take it, parse it, format it, add it to the mini buffer candidate list. So that's what is happening in the background when you're running consult-omni searches. So if we want to do this for something like Wikipedia, we can of course do the exact same thing that we did here. So now I'm going to change this function that we defined before for collection as a collector to what we had up here. All right. And then at the end, what I do say is return a list of results, because remember, this collector function should return a list because that's what we expect in consult-omni. So if I do now consult-omni demo and I say Emacs, you can see that the response from Wikipedia, the whole response is being shown here as a mini buffer candidate. Of course, this is not useful. We probably want to parse it and format it, etc., which is what we're going to do next. So now let's do some cleanup. So again, I would do the exact same thing. I take the result. I am going to, instead of just sending Emacs, which we already took care of here, we are sending the input to the Wikipedia API. So we change the URL based on the input from the user. And then we do the same thing, but with URL retrieve, we take the URL, but now we change this function. So instead of just setting the result to the entire buffer string in that buffer, I say go to the end of headers. So I don't need the headers part. Then parse the JSON data structure that we are retrieving from Wikipedia. And then in that JSON, based on the knowledge of what Wikipedia returns, I am parsing the results, the JSON data structure, and breaking it into individual candidates. And then I return a list of these candidates. And for each candidate, similar to what we did before, I am just adding text properties that add faces, and somewhere down here, I am defining a source key. Remember, we need this for callback and preview function, title, snippet, URL, etc. So that's what we're doing, parsing the response that we were already getting. The rest of this part is still the same. We're doing some waiting to make sure that the results arrive. So if I now evaluate this and run the exact same search, now you see that I'm getting a list of results from Wikipedia, and I'm also formatting it nicely. I see the name, some snippet for what is coming, the response that is we are getting back, and also the URL here that is not in the view. And here, if I scroll, you can see the URL. All right, that's all good now, but this is still not the right way of doing things, because this waiting that we are doing here essentially makes everything synchronous again. In reality, we do not want to do this waiting and then returning result. What we want to do is, instead of this waiting and bringing the results in and returning the results in this collector function, we want to say within this callback function of URL retrieve, we want to say take the results, parse it, and whatever is already arrived and parsed, add it to the mini buffer candidate list using the backend of consult and consult-omni. So that's what we're going to do next. So in this case, we do it again, the exact same thing. We take the URL, set the URL based on the input. We use the URL retrieve. Now, one thing that we changed here is that instead, this function not only takes input, now also this is used. We are doing this with CL define to use the CL library here, and therefore it can also take a keyword input called callback. So the format that I would normally use for sources is something like this: input and rest args and key callback, and allow other keys as well. All right, just to make sure that we don't have a lot of errors and issues if somebody uses some other keys with these functions, or if we need to use some other keys within consult-omni. So now, inside this callback function for URL retrieve, once I get all the results and do the same parsing of everything, at the end, instead of setting some results, which we were still doing up here with this in this let binding approach, where we had this empty result variable, and then we were setting the result. What we are doing here is then within that same callback function, we call the callback input of this collector function that is defined up here, and we call this callback on the list of results that are formatted. Now, in the backend of the consult-omni, I have defined things in a way that this callback, so when you use this macro to define source, this callback will be the function that gets these formatted results and adds it to the mini buffer candidates list using functions and backends that are already defined in consult, and maybe adopting some of it for consult-omni. So in this case, once we do this, once we define the collector function that accepts a key callback, then we can go back to our defining source and change the type to dynamic. This means when I say type dynamic, it means that my request function here accepts a callback keyword. So then consult-omni can take this request function and send the right callback that will be used to add candidates to minibuffer to it. All right, everything else will stay the same. So if I now evaluate this and do the same search, or actually, sorry, I think I did not evaluate the new function definition, so let's do that. All right, so now you can see that the source is working as intended. Note that in this specific case, because URL retrieve from Wikipedia is not going to get the data in chunks, it's just going to get the whole data and put it in the buffer and then run this callback function. It's still not very different in terms of timing and performance from just waiting and checking whether the results is done or not. But it has the advantage that we are not waiting for setting this result and then going back and adding. As soon as the results arrive in this callback function, it will get added to them. So the difference is very subtle in this specific case, but it helps with defining dynamic sources in this way, especially because with some other sources, it may be that the data then comes in multiple chunks, not in one chunk. And in that scenario, this callback function takes care of adding each chunk to the mini buffer candidate rather than us waiting for all the chunks to come and then add it in all in one part. All right, so that's dynamic sources, which is essentially saying we have an eLisp function, a request function that takes this keyword callback and runs this callback on the candidates that arrive, whether it arrives 1 second later or 5 seconds later or 10 seconds later. All right. Now, what about async source? Async source is very similar to dynamic sources. We are again going to run some async processes, and the results may arrive a little bit later, but the format is slightly different because in this case, we want to run some command line arguments in a shell maybe. So we can, similar to what we did with URL retrieve, if you want to run some command line synchronously, you can use something like shell command to strings, to a string, and here, for example, I am getting a list of files and directories from this directory here, right? Or if you want to do a little bit of a better job than just shell command to a string, maybe you want to use call process, which then takes a program like ls, and then takes some inputs for what to do with errors and for what to do with the returns, etc. And then extra variables that will get passed to this command line, similar to what we saw with the URL retrieve synchronously. Here you can also see that I would then say with current buffer of buffer, run this call process command and then set results to the buffer string. So if I do this, I would get the same results, the list of folders and files in this directory. Now, let's talk about how you can do this asynchronously. For asynchronous process, you can use something like a start process, where you would then give it a name and a buffer, and then again, name of the program and extra arguments that gets passed to that program. And then the rest of it is more or less the same. You start this process, give it a buffer, so it will do the it will run this process in that buffer, so you will see the results in that buffer, and then you say go to that buffer, get the results, and return the buffer string. So if I do this, now you see it's empty, because as we saw with URL retrieve, if you run this asynchronously but don't wait long enough for the results to arrive, you still have an empty buffer. So then we can do similar to what we did before, add a timer, check if the results have arrived, and return the results. And now you can see that the results are here. So this is the exact same thing that we saw before for URL retrieve, but with command line programs. Now, in reality, you can even go one step further. Instead of a start process, use make process, which gives you more control and more features. But for this video, at least, this is good enough to understand how this asynchronous process of calling command line arguments work. Now, for consult-omni, what we want to do is, so before with dynamic sources, we had an elist function that would go collect candidates, formats them, etc. With consult-omni, all we need for a collector function that is with async sources, so meaning running command line programs, all we need is a function that returns a list for what should be run in the command line. So the name of the program goes first and extra arguments go here. So if I just change the collector function that we had before to returning this list, let me see. Looks like I have the same copy here, so we already did that. Now, before with the dynamic sources, we had the formatting and parsing everything in one collector function because it's easier to do things that way, because for different sources you may have a very different type of results, and the parsing and formatting has to be defined per source. For async sources, this is not the case. The results is going to be parsed based on line by line. From the command line, whatever command line returns, we want to parse the results line by line. So instead of doing it all in one function, we're going to define a transform function that essentially runs this collection function, this command line arguments, and then this transform function essentially goes line by line and formats each line. So this transform function essentially replaces formatting for async functions compared to dynamic functions. All right. So in this case, for example, I say go over each line, which would be each file in this case when we are doing ls. And if the query here, which is the user input, matches the file, then keep that and do some formatting, maybe add some text properties, some faces, maybe add some path for that specific file, and then again at the end return this proper text string with properties, and importantly add this source demo. All right, so now I define this transform function, and then I will redo this defining of the source where I say the type is async, now meaning that this request function that I have here will return a list of arguments that are parts of a command line program to run. All right, so when I say this type is async, consult-omni will take the results from this and tries to make a process in the background that runs the results of this function as command line arguments, gets the response, and then tries to then pass the response, which is all the lines from the command line argument that was returned, to this transform function that we just defined, and then shows them as candidates. Everything else, callback, preview, etc., will remain the same as what we saw before. So if I now do this, let's see, okay, let me see, consult maybe. Now you can see that I am getting the results of listing files and directories in this example directory that I defined before, and returning everything that matches consult. And just to show, maybe if I get everything, so if I pass the dot star for regexp pattern that matches everything, you can see that we have a bunch of more folders in that directory, but if I pass Emacs, for example, I will just get the responses that match Emacs. And in terms of callback, etc., everything is the same as before. Okay, now let me see this part. We don't need, we already saw this. This is also, all right, we have seen everything here. So the last thing to say is that there is, of course, a lot more features that you can use when you use this consult-omni define source. So it would take a name that will be used in the interactive command. So whatever name you use here would then be consult-omni dash this name. So for example, we use demo, and you will get two interactive commands, or depending on how you do the configuration, maybe one just for dynamic, or one for static, or both. That's also possible to customize that, but you get interactive commands that are called consult-omni dash the name that you put here in consult-omni define source. And then you have to pass a type, otherwise it doesn't know how to deal with this request function. So whether it's sync or dynamic or async, one of these. If it's synchronous, it means that this request function is gonna return a list, and it can take an input from the user, and it will return a list. If it's dynamic, it says it will take the input from the user, goes do something with that input, maybe finds the right API URL to call, and then in an asynchronous process adds the response one candidate at a time to the mini buffer candidates. And if it's async, it means then that this function would return a list of arguments that will be part of a command line argument, runs that process, gets the response, and in this case will then use this transform function to format them. If the transform function is nil or is identity, then it doesn't have to do any formatting. There is, of course, more. There is filters. If you want to then filter some results, especially for async commands, you can use this. There is on setup, preview, return, exit, similar to what we saw for preview and callback before. We saw this on new. There is this variable require match, which means you can force the source to not take new and non-existing candidates. It has to be one of the candidates that returns. If you set the require match to T or true, if it's nil, then it can also the user can also select new non-existing candidates. There is this variable that is now called interactive, not static anymore, which can either be dynamic, static, or both, which means that make the interactive command only make the dynamic interactive command, or only make the static interactive command, or make both interactive commands. There is lookup function that we saw before. There is grouping function that you can change. This narrow char is what gets used in the narrowing function. So if, for example, you say B, that would be, or B like this. This is what we used earlier for Brave. So then that user can use B to select that source, category, etc., etc. You can go look at the README, especially the Docker string for this macro would explain every one of these in more details. And you can also look at consult that also has uses some of these same keywords in, for example, consult read. And then beyond that, if you go to the repo and look at this file, consult-omni.org, which let me open here on my local file. If this file is essentially the one single source of truth for the entire repository, everything else gets tangled from this org file in a literate programming approach. So here, if you go down to the section that says resources and go to single source definition, you can see definition for every source. And you can essentially use these as some cookie cutter formats because they all more or less have the same format. For example, if I look at this first one, header is for the elisp file. It's not really nothing that you need to change. You just need to change some names here. Then, as I said, you can define some custom variables, maybe some other variables that are not custom. Then helper functions, for example, a simple preview function here that says ignore because for apps we don't need really previews. Callback format. And then here we have a bunch of functions that help building these collector functions that at the end looks like this. As I said, this is a dynamic one, maybe with input args and callback. And then at the end, we run this define source with different variables. And that's about it. So you can read the source in this consult-omni.org file, and that should be a good source for you to see different examples of how every source is implemented. And based on that, you can also define your own new sources. And that's it. That's pretty much everything that was to tell about Consult Omni. I know this was kind of a long video, but I think it's good to have everything in just one place so that users, especially advanced users and power users, can come back and look at different parts of the package and understand different features and how to do new sources, etc., etc. If you like what you see here, please like and subscribe. And also, please sponsor me on GitHub so I can do more of this work. I can make more videos. I can improve the package. I can spend more time on the package, on the videos, everything else. And with that, I just say thank you all and have a great one.